today will be mostly dedicated to presenting lovely papers. And we'll start very soon. Our first session will be about languages, recent language developments, live coding languages, obviously. Just for the format, we give each speaker has 20 minutes, and we will do question and answer session, or if nobody has any questions, maybe a little discussion panel at the end of each session. So if you have any questions, keep them till the end and we'll figure it out. There was something else I wanted to say, but I forgot. So without further ado, first paper, Sardine, by Raphaël, Maurice Forment, and Jack Armitage. The stage is yours.
Hi everyone. I don't have much time, so a lot of slides, so I will try to go fast. And so this is Sardine, and I'll just play you some sound just to show that it works and that you can make music with it. Slides. So Sardine is a modular Python environment for live coding that I've been working on for the past year. It's almost a year now, and we've been trying it like intensively at Algorithms and for prototyping stuff in France with our friends that are here on the third row. So yeah, we played quite a lot with it already, and it's nice to play with it and to see it crash because you coded it, so it's cool. We're also giving workshops with Sardine. This is a workshop we did at the beginning of the month at Gram in Lyon, using Flock. And yeah, we are trying to get up to speed with the other environments, like having a nice editor and everything. I have a lot of slides, so I will just try to tell you what the project is about and what Sardine is and what we want to do with it. So I'm a PhD student at the Université Jean Monnet of Saint-Étienne in France, and I'm working on live coding, and Sardine is part of my PhD. It's like the technical part of it, I would say. And this paper has been written also with Jack Armitage, that most of you already know. He's been doing some prototyping with Sardine at the Intelligent Instruments Lab in Reykjavik. And yeah, we have a lot of contributors already, so I wanted to give a shout to them, because a lot of people, not even live coders, working on Sardine, so it's great to see that. Yep, so Sardine started as a tiny example for my PhD. I wanted to show what a live coding environment is and how it's implemented using a high-level language. But then it escalated. It went like crazy, really fast. So we tried to recreate different design patterns and different ways to live code using Python. Then we thought about like setting up a playground for many different live coding notations using Sardine, like having different languages blended together in the same space. And then we rewrote everything again to make it like very modular, so you can rip the head off, change the clock, change the parser, change everything. And so it's very modular, and you can basically fine-tune it for whatever you want to do. And yeah, nobody knows how to use it, so we spent a lot of time to just document, and teaching the system to as many people as possible, so they are confident using it. So yeah, basically users are leading the development. French live coders have always like requests they want to see implemented in Sardine, so yeah, I'm trying to do that. And this is Python. You already know Python, you know that it's slow. So we are trying to optimize it to make it like very powerful, very accessible. And it works quite well. So yeah, everything started from this, which was a very hacky demo I made on my computer a few years ago. And then it's been a series of rewriting. And so yeah, Sardine is designed to be very, very generic. We are using temporal recursive functions. We call them swimming functions because it's funnier. It's a pattern that most of you know already. Basically, we just do recursion, and this is how we speak and think about time and timed operations. And we try to support as many different patterning types as we can. So like you can do imperative patterning, declarative patterning, functional patterning, because we don't want to lock users in a specific way to think about their code. And yeah, we have to now implement everything that, like all the cool things that all the other environments already have. So like able to link support, collaborative jamming with using Flock or whatever. And yeah, so basically a good part of the development is getting up to speed with everything else. And also one thing that I find very fun to do is opening up to multiple pattern languages. So there is a default pattern language that you saw already in my very short demo, which is called SPL. It's the Sardine pattern language. It's a programming language in itself. You can do arithmetic. You can file your taxes using it. Like you can, yeah, do a lot of different things. It's very basic, but we like it for that reason. And then if you want to go into specific things, specific usage, you can choose, for instance, like the Zephyrs numeric language. There will be a presentation this afternoon about it, which is a parser dedicated to chords and melodies and generative melodies, only using numbers. And also, because it's Python, and we know that people like to write Python, you can just basically hack things, hack your own functions, and add some stuff. Yeah, and in the future, I would like to see more things like, for instance, where is the, yeah. So maybe why not like a tidal parser in Sardine, maybe also like a very object-oriented library for writing patterns. And we are also doing some sort of code archaeology, because in France, there was a lot of people live coding without calling it live coding a few decades ago, and they have been showing us their code. And, but everything is written in Lisp, so we have to write everything again in Python. And so yeah, hopefully we'll implement some things like this in the future. There is a wonderful package called time generators, which is written in Lisp, and it's a very powerful syntax for writing patterns, yeah. And okay, so modularity, we support MIDI and OSC protocols, so OSC in, OSC out, MIDI in, MIDI out. And you can pattern MIDI and or OSC, or you can also listen. So like you can query controller values and everything. And yeah, some people have been using Sardine as some sort of middleware. I have a lot of questions about it online. So like, how do I listen to something with Sardine and just play a sound or something? So not only live coders apparently are interested in Sardine. Already say that. Yep. That's okay. And yeah, of course, there is other reasons for developing Sardine. So I want to control my studio. I have a studio at home, and I want to control everything from my computer. So this is one of the reasons I'm developing it. And also collaboration with visualists, with people working with machines or like complex setups and everything. And also, just like there is a lot of different propositions for live coding with Python, but there is nothing that is very like general and tries to eat everything, and that's what I'm trying to do, basically having like a huge Python package that can help to do that. Few words about the architecture and design of Sardine, which is a bit weird, because we are not using the Python interpreter, like the basic one. We patched our own interpreter to be more reactive and more faster. Basically, we went to the Python-based repository and we copy-paste the asynchronous interpreter, and then we patched it. So this interpreter is called Fishery, and a lot of things revolve around this interpreter. So you see, like Sardine is just a library, but a library that is automatically loaded in Fishery. And then it can spawn things, like it can spawn its own instance of SuperCollider, which is what I was doing previously. So you don't see SuperCollider, it's just there. You have an interface to it. And then you can send messages, so like MIDI, OSC, and also super.messages, which are like custom OSC messages. There is a lot of diagrams in the paper if you want to check how everything works. We have been trying to document everything in a nice way. So if you are curious about how it all sits together, you can just read the paper and like everything is well explained. Yeah, I need to go fast. So yeah, the core components is the Sardine, the library itself that implements like clocks, patterns, input, output. Fishery, the interpreter, and the very odd Fishery web, which is a Svelte application that spawns its own Python interpreter. And basically it's like an IDE for Sardine. It's a work in progress, but it's cool to have it for workshops and things like this. And then possible backends, as you can imagine, SuperDot, MIDI, OSC. And also you can write your own definitions for, like, if you have a synthesizer at home with 50 parameters, you can write a custom MIDI function, like custom MIDI, we call them senders. A custom sender with the 50 parameters, and you can pattern them all together in just one line of code, which is very cool. And yeah, we have something that is very reminiscent of modern web. We have some sort of reactive environment called the fishbowl, because we are talking about sardines. And so the fishbowl handles communication between all the components of the system. It propagates things, so like if someone is telling, I'm crashing, please stop everything, it will stop. So that's nice. Yeah, basically you plug or unplug things from the fishbowl, and that's how it works. You can, for instance, swap the clock. Well, I never did it live, but I'm sure that it works, like just swapping the clock live and doing things like this. And yeah, so everything is modular, and it works by declaring components of the system that you want to add or remove. So like, I want to listen to this thing, poof, I listen to it. And now the fishbowl is aware of it. Yeah, so basically, you get to decide what you want to get out of it. Some people are not using SuperDot at all, they just send MIDI. Some people just send OSC. Some people would like to do everything at the same time. So yeah, that's very open. And for the implementation itself, everything is async.io, the very frightening async.io package for Python. So, and it's the code base is very object-oriented. So like we have abstract classes, we have a lot of different classes and everything from stuff here and there, and implementing the different behaviors that we want to see. And the code base is fully documented. Like we wrote like entire paragraphs in the code base, so it's cool also to check it out if you are interested. Now for the syntax. The syntax, it's frightening. There is 4 lines already on the, but you will see that we can do a lot with it by abstracting over it. So the base mechanism is the swimming function. The swimming function is just a recursive function. So you use the swim decorator that you can see on the screen, line 1, and then you have a recursive call to a function called again, which is basically swim but hidden, yeah. And then things are recursing, so like this is timed recursion, so there is this magical p argument, which is called period. One periodical is 1 bit. And then you iterate over stuff. And by iterating over stuff, you create your patterns. Sounds very basic, because it is. it's meant to be, it's designed to be very, very generic, and as you can see, it's also very verbose. Like, if you can write your code in a swimming function, and most people do it in algorithms, but I will show now that you can abstract things. So yeah, verbosity is not bad. For instance, if you want to do something very specific, you don't want patterns. You just want a function that recurs in time and act on it. So you can leverage swimming functions to do weird things. For instance, we have tried already in a workshop to live code the file system, so like creating folders and populating it with files. It was very fun, but also very chaotic. Yeah, so think of the swimming function as templates, and then you have to abstract over it. So it's like a flavorless version of live coding. And so as a demo, and also for my PhD because I need it, we implemented a few languages that look very suspiciously like Foxtrot or like SonicPy, you'll see. So like this is, we call them surfboards, and they look a lot like Foxtrot, if you are familiar with Foxtrot. So you have a player, PE, PC, PB, PD, and you associate something with it. So in that case, it's a D object, and the D object is dirt. So it's like super dirt. And then all the arguments can be patterned, so it's cool. It's fast to write, easy to teach, and that's why we use it a lot. But you can also do weird things, like on the left, you see something that looks a bit like SonicPy from Sam Aaron. So like you can do sleep. Obviously, it's not Python sleep because it's we patched a version of sleep. And on the right, you can see multiple, like multi-language live coding. So we have multiple pattern languages. So DA and DO are using ziffers that you will discover this afternoon, and the third line is using the SPL pattern language. And it's fun but very confusing at the same time because you are on stage and you have to speak 5 different languages at the same time. But yeah. So yeah, I'm speeding up a bit. These are the key design choices. So make it very generic, give things on demand to the user, and have a good documentation so they can discover. Yeah. Yeah, Sardine in the wild. So we just scroll very fast on the things we did with Sardine already. So Jack Armitage, he has been doing some very weird stuff using Vulkan and 3D and GPUs, and so basically live coding generative models using Sardine. So you can see that most of his code is using NumPy and things like this. And then he has like a GUI loop using a swimming function and a patterning loop, and that's everything. Yeah, like it's very cool to see how it works. He has some videos on YouTube if you want to check of him patterning his models. We also have some fully composed pieces using Sardine. So this is an electroacoustic composition by Harmonics. And also, of course, algorithms. So like a lot of algorithms in France, Paris, Lyon, everywhere. This is a big swimming function with a full piece inside it. So like you can just live code this and yeah. Algorithms as well, but using the over syntax. Remy, which is in here. Live coding Sardine in Saint-Etienne. Also the satellite event, the beginning of April, where we live coded a lot with Sardine. Documentation, we wrote a big documentation. So like you can go and read it. Everything is explained, even some of the hidden things. And also, like I said, the code base is very well documented using like this huge doc strings. And I don't have time to do this, but let's try anyway. So yeah, Python is cool, Python isn't cool, because Python can break in a lot of different ways. It's very hard to package. Modularity is cool, but try to teach a newcomer that he has to plug things together to make it work. It's hard, and you have to explain what MIDI is, what OSC is, and etc. And also growing a community of users is super hard, because you have to be awake every time. Like you receive strange messages at night, and yeah. So, yeah, managing Python environment is very difficult. Python distributions are very messy as well. Bundling is terrible. Python is slow, but we love live coding, so yeah. But everything works. We did a lot of work about this. We spent like a few nights making it work well. Yeah, and so like I said, sometimes for newcomer it can look like a bunch of loose components floating around, but there is also an application you can use just to configure Sardine. So like adding things, removing things, choosing the clock, etc. And yeah, so this conclusion, Sardine is waiting for you. I just hack it. We are performing with Sardine at the end of the ICRC, and this afternoon there will be a presentation about Zifers by Mika Alonen, so be sure to check it out, and thank you.
Thanks, Raphaël. Never been much into seafood, but this might change my mind. Next, we have Felix Roos presenting Strudel. Just as a hint, also, if you go to the ICLC website, all the papers are available if you want to read them. Bios of the authors. We have compiled a lot of information, and most of it is available by now. If you feel that something is missing, please let us know. So, yes. Now, let's give the stage to Felix.
Is it working? Ah, yeah. Okay. Yeah. Hello, everyone. I'm Felix Roos, and I'm a programmer slash musician slash random guy from the internet, and I'm excited to talk about Strudel, which is a project I did together with McLean in the last year or so. And what is Strudel? It's a faithful port of title cycles to JavaScript, and also a zero install live coding environment for the browser. It's free and open source software, it's modular, hackable, shareable, and embeddable, all that stuff. And you can even embed it in slides like this. So let me give you a little test drive. Yeah, just to give you a little taste. Okay, let's talk about the history. It was like a really wonky journey from Haskell to Python to JavaScript. And in the beginning, Alex did a rewrite of title in called Remake in Haskell. And then this was ported to Python under the name of Vortex, and ported again to JavaScript under the name of Strudel. And then I somehow found the project and started developing the editor for it and other things. So let's do a quick comparison. I hope you know title more or less. So I'll just compare the title syntax with the JavaScript syntax. And in the mini notation works kind of the same, mostly. And here the only difference is that you have to use parents all the time to call functions. So, but mostly it's the same. In title you have this magic hash operator for composing patterns and modifying the values, which is not available in JavaScript. But therefore we use the method chaining approach. So it works the same. And similarly, in Haskell you have this dollar operator to wrap things, which is also not available in JavaScript. We could write it in the same order in JavaScript like that. So you have nesting here, which is kind of hard to read. So we decided to also flip that and add it as a method chaining. You can't overload operators in JavaScript, like in Haskell. So we also have methods for adding, multiplying, subtracting, and so on. And again, you can wrap things with the dot operator and keep everything on one level to make it easier to read. And I can try. Yeah, I can't scroll further like that, sorry. Yeah, next time it's better. That's smart. Okay. So, and you can also do higher order transformations with functions like partial application, similar to title. And there are some edge cases where it still doesn't work, but we are working on that. And here's an example of a combination of things, and you always have this thing where the order of control changes. In title you have like from the bottom to the top, and in Strudel it's like from the top to the bottom or from left to right. But the rest is kind of the same. And yeah. And this is also called a fluid interface when you use method chaining to express domain-specific languages in regular programming languages. So now I have to resize that. Yeah. There are different ways to use Strudel. The main way where we develop it is the REPL at strudel.titlecycles.org. But you can also use it inside flock.cc for collaborative coding. And there are also a bunch of NPM packages, like 16 or what, where you can use parts of Strudel and use it for your own projects. And there's an embeddable web component that is used in a nice plugin for Mastodon, where you can automatically replace these Strudel links with integrated editor, and also a discourse plugin which we use in the Club Title Cycles forum, which does a similar thing, which is pretty nice. You can also fork the Strudel repo and place your text files inside a specific folder, and then deploy that page with relatively few steps to get a swatch-like visualizations of all your patterns, and a little bit inspired like by textile swatches, and then you can click on them and play them back. And you will also get a fixed version of Strudel when you fork it, so your things won't break when something changes. Okay, let's look a little bit at the REPL. REPL stands for read, evaluate, play, loop. And this is it. It's a basic player interface. Okay, I haven't loaded the aim and break offline, but you get the idea. And you can shuffle through examples, kind of like in Hydra. And you can share links. There's also an extensive documentation with interactive snippets. So this is the best place to get started, where you can just learn all the functions with integrated visualization and everything. Yeah, just exploit yourself. I don't have too much time to show everything. And let's talk a little bit about the visual feedback, which is one of the nicer features. There are two kinds of visualizations going on. One is the highlighting inside the source. This is similar to the feed-forward editor and also Živa. And the second one is the piano roll visualization, or more generally a way to draw events, which is currently only available as a piano roll, but it could be other things. And let's just look at that. So at the top you see the in-source highlighting, and there the representation in a piano roll. And yeah, then let's talk a little bit about the architecture of the REPL, how it all fits together. We have basically 3 steps. The user writes and updates code. This code is then transpiled and evaluated to generate a pattern. There's a scheduler running in the background, querying that pattern to generate events. And those events then trigger audio or anything else you like. The user code does some kind of magic with transpilation. Transpilation means you take a string of code, in this case JavaScript, parse it into a syntax tree, transform that tree into another representation, and then generate code back, which is done to do some functions that are not available in JavaScript, like, okay, I'll do it again like this. Yeah. So in Strudel, we transform these double-quoted mini notation strings into actual function calls, and also append the location of the mini notation snippet in the whole code, which we then can use to highlight things. And similarly, the mini notation uses a custom parser in a PEG grammar, which is parsing expression grammar, I think. And you also get an AST from a mini notation string, a syntax tree, and you can transform that into a pattern, and looks kind of like this, where you have the mini call, and then this is transformed into actual function calls from Strudel. And the cool thing about that is you also get source code locations of each item in that list, in that mini code snippet. So you can use that for the highlighting. So we have basically 2 kinds of locations going on to work on that. Okay, so now we have the pattern from the user code, and then it's queried, which is like the basic mechanism of Tidal to generate events from a pattern inside a specific time span. You can look at an example here, a very simple pattern. When we do .log, we will get logs of the pattern. And then you get these events, and on the left there are the time spans for when they are active, and on the right there are the values, and these can be used to do things like playback in the web audio API. So up until till this point there are only objects in time or values in time, and you can plug anything on it, and the web audio output just uses these values to select samples and apply effects. And yeah, you can change the sample. Also oscillators are supported from the web audio API. And there's also an experimental implementation of General MIDI sound fonts. Good old glass piano. And there are a bunch of effects in it, like everything you would expect, not too fancy, but filters, delays, bit crusher, and a few things. And besides the web audio API, there are other ways you can output and pattern things. Another way is using OSC via OSC.js. You need a specific server for that, but it's just one command line. and then you can use it for SuperDirt or other programs that expect OSC. There's also a C-Sound output, which works with the C-Sound WebAssembly build, where you can write your own synthesis or use existing ORC files with instruments. And you can use WebMIDI and also serial via web serial to make robots dance like Alex does. And everything of that works inside the browser except OSC. So the only thing where you need external tools is when you use OSC. Okay, now let's talk about what's bad. Generally, the dynamic typing of JavaScript is a bit hard to work with functional reactive programming, which is the paradigm that Tidal uses when it gets more complicated. So it's hard to track down where, what are the types and what are they doing. And we also had some problems with fractional representation in hot paths of the code where many calls are generated, because JavaScript doesn't have a built-in way of representing fractions. So we use a library for that, and when you do something wrong, you get too many approximations of fractions, and then it's horribly slow. But we worked around most of that. And yeah, it's also much more verbose in JavaScript to implement function composition, and it's also a point where we don't have a solution yet, but hopefully we will get there. And there are some trade-offs to the fluent interface method chaining approach, where it's a bit more harder to handle errors, and yeah, a few things. But there are also many good things about it. You don't have to install anything. It works on any platform where a browser is available. And it also works surprisingly well on mobile devices. So you can just open your phone, click a link, and then play the pattern. And the visual feedback system is really, really good for teaching and learning, because you just see what's going on. Not just for beginners, but also when you're writing it, it's just adds another dimension to the music. And the fact that it's written in JavaScript is good for contributing, because many people speak that language, and so it's easier to get help from people. And what's also a nice feature is the instant pattern sharing, so you can click a button and get a link and send it around, and people can remix that and create a new link, or you just have an idea, send it around. We also used it in development, because you can write any JavaScript code. You can also implement new functions of the system itself and then send that around, so it was very useful. Yeah, and generally there was a little two-way flow of features between Strudel and Tidal. So some features landed in Strudel first and then fed back to Tidal, and the other way around, which was, I guess, fruitful. And it also brings the mini notation to Hydra and Živa, which are also projects in JavaScript, and Živa already has it. I think Hydra, the experimental approaches, but maybe it will come in the future, which would be very nice. Okay, so what can we do in the future? We will build the Strudel community in a healthy and slow way, not too fast, so don't tell everyone. We will implement block-based evaluation at some point. So at the moment you can just evaluate everything at once, which is a bit hard for live coding, because if you make an error you can't evaluate anything. So we will bring that feature of Tidal also, and maybe add live collaboration inside the REPL itself and try approaches with that. And also what I really like is to add more audio backends and maybe alternatives to the web audio API, because it has its limits and there's so much cool stuff out there that could be tried. And also very interesting things can be done with interface, because in JavaScript it's really easy to throw in HTML slider or anything and use that for controlling compositional parameters or anything. We already experimented with that, but it would be really cool to have a standardized way to do that. And also other features in the REPL, like time scrubbing the timeline, or some kind of visual notations, AST, plugging, whatever. We have some crazy ideas. And yeah, that was it. Thank you very much to the organizers and to the title community. Thanks.
Thanks, Felix. That was amazing. Thanks for the crew for fixing the sun problem and risking their lives climbing up on the roof to fix it. An applause for them, I suppose. From this delicious piece of pastry, we'll take a big leap into Slavic mythology, because Roger Pibernat will present Živa, if I pronounced that correctly. So, you must know it, Luca. Let's give the stage to Roger.
Sound, yeah. Where is it? Where's the cable? Okay. I'm working on it. Hold on. Good morning, my name is Roger. I'm an illustrator. I'm not a musician, or not a formed one, not a coder. But I started live coding maybe, well, I think it was in 2011. I went to a workshop by Thor Magnusson, and he taught us SuperCollider and Ixalang, and it got the itch into me, so I started live coding with Ixalang, but just at home. I didn't perform until 2018, I think. And I started also diving into SuperCollider without knowing anything about audio. I didn't know what a sound wave was, because I came from the graphic side. And but I started digging into it, and I really liked it. And then eventually Ixalang got deprecated because it worked only on Mac OS with the Cocoa library, which is the Windows system. And then I had to learn other languages. SuperCollider was a bit daunting, so I started looking to other languages. I discovered SonicPy, and I tried Impromptu. I really liked SonicPy, but I discovered that if I wanted to do some synthesis, which I had already learned by then, I had to go back to SuperCollider and code it in SuperCollider. And I kept looking around. I stumbled into tidal cycles, and I started using it quite intensely. And then I had already performed by then, and I started using it performing. And after that, I realized that I had the same problem, that if I wanted to do some synthesis, I had to go back to SuperCollider and code it. And by the same time, I discovered FM synthesis, which I really loved. And I wanted to do it with tidal cycles, but I couldn't. And then I just posted a message to see what I could do about it, and Alex suggested that I made a pull request to make a Super FM to the tidal cycles, and it eventually got accepted. And after that, I just, tidal cycles, I really liked it, but it's not my way of thinking, so I just kept on going through other languages. And I tried Fluxus. I tried, well, let me put the slide so I can remember. Overtone, I tried Orca, but I always had the same problem that I had to go back to SuperCollider to do some, I don't know, if I wanted to make a really stupid synth, I had to go back to SuperCollider and do it. Or to SClang, because they all use SuperCollider in the background. And then I found Chucklip, which is a library it's a quark, a SuperCollider quark, that it's inspired by Xlang, and I got really inspired by it, and I started digging into it as well. And it uses the SuperCollider pre-interpreter, which is cool because the pre-interpreter is what you do when you evaluate code on SuperCollider. You get to parse the code before it gets evaluated, so you can put whatever you want in it. You can make your own syntax. And I really liked it, but it was kind of hacky and unstable. I tried doing my own stuff with it, but I kept breaking SuperCollider all the time. And I wanted to still be able to use SuperCollider code because I already knew how to use it. It got me a long time to use it, to learn it, so I wanted to use it. And in this way, I had to, it was too much work to try to merge the two things. And by that time, I started thinking of making my own thing. And I tried different approaches until I came to realize that in SuperCollider, the syntax is flexible. I mean, you can write not only you cannot only achieve the same purpose in different ways, you can write the same expression in different ways. There's different syntaxes embedded in SuperCollider. So I started looking into that. And I realized that it was very easy to implement my own methods in my own extensions and put musical stuff into really abstract classes like sequential collection and patterns and so. And by the time, also, Glenn Fraser, which is a good friend of mine, he was starting to use Bacalhau, well, to code Bacalhau, which is based also on tidal cycles. And it's done in SuperCollider using the same method as Chucklip, which is the pre-interpreter. And I wanted to use it because Glenn is a really great programmer, and but he backed me off, telling me that he just wanted to play with it. He didn't want to do anything stable, so his code would probably break my code very easily. So I just got, to make my own thing. And of course, with being a graphics guy as I am, I tried Fluxus, I tried Hydra, even coding with shaders. And that got kind of everything soaked into me. And I just came to realize what my ideal live coding setup would be. And two things that I realized in most languages is that they usually use SuperCollider in the background. So it's two systems that you have to be running. Some of them don't, like Sonic Pi, because they have their own, they talk to the server, to the SuperCollider server, not to SClang. But nonetheless, you still need SuperCollider if you want to do extra stuff with it. Another thing is that the short syntax, which most languages already solve, I mean, that's why I think there's such a large collection of languages, because everyone is trying to solve the SuperCollider problem, which is the syntax. It's very verbose. It's very rich, but it's really, to live code with it, it's a pain. And it's very versatile. And that's a thing I really looked into it as well. I really wanted something that was easy to play and stop, like with tracks. Chucklip did that very well. So I took the idea from that. I wanted, as I said, a self-contained system. I wanted both musical approaches, the sample-based and the synthesis-based. And I wanted to be able to do both patterning and modular patching, like a modular synthesis. And that led to, well, two things in my system. One is that it needed to be quick to set up and interact with. So when you want to live code, you just want to go in and play and not have to, in SuperCollider, you have to load if you want samples, you have to load them, you have to put them into collections and try to figure out a way to sort them and to get into them and what to do with them. So I developed a quark called Živa, which Živa, by the way, it's a Slavic name that means alive. And it's called Živa because I developed this as a resident in Ludmila last year as part of the On the Fly project. And it's like a tribute to their welcoming. And I developed this quark, and it has, well, the class itself, it's just a bunch of methods to set up the system and interact with it quickly while I'm live coding. And there's a boot method that you can, if you pass it parameters, you can pass it the number of channels, if you want more memory, the typical stuff you would do in SuperCollider server options. You can just put them in there, and then it will boot up just with one function. And let me try if it works. It doesn't. Okay, so now we're running. Then I wanted some way to poll the system on what's going on. No? I don't remember the name of a synth or a sample or something, so I made a function that I could poll the system for that, called sounds. And then here in the post window, I get all the list of the synths that I've loaded, because I haven't loaded any samples yet. I wanted to sample to load the samples as well, really quickly. And from that, I drew the idea from SuperDirt, because I think it's very well implemented in that regard. And well, you pass it a path, and it loads all the samples, and it tells you how many samples are there in each particular folder. And then I also have a collection of effects. I don't know if we'll get the time to get into there, but and here it's well, I don't know if you can see it, maybe not. No, well, you'll see it later. Well, there's just a list of effects like a tremolo or a bandpass filter, you know, whatever, reverb, all that stuff. Then there's also rhythms that I implemented using arrays, just simple arrays of ones and rests. And then you can chain them. I'll explain later how to do that. You can chain them to just regular arrays. So you can get melodies or rhythms or whatever with quite easily. And then also there's a controls function that what it does is you can ask what that synth, it's better for synths because for samples it doesn't make sense. But for synths, it tells you what parameters are available so you can tweak them. And then there's the syntax part. Before developing Živa, well, Živa, it's like where I fell into. Because while I was doing SuperCollider, I started looking of ways to quickly modify patterns. I was really playing with patterns back then. And I wanted to find a way that it was easy to modify patterns, but having presets, like a little bit, no? And I looked into pdef, pbindef, pdefn, there's a whole bunch of them, pset, I think, to change the parameters of some synths while they're playing with patterns. But none of them quite worked until I stumbled upon pchain, which kind of seemed to solve the problem. It's if you don't know pchain, what it does is you give it a list of patterns, and then starting from pattern n on the top line, like from here, it will get that pattern, namely the pbinds. It works better with, well, I use it with pbinds. And then you pass it a pbind with some parameters, and then you chain it into another pbind with the same parameters or others. If the parameter is repeated, the first one will overwrite the second one. If there are different patterns, they will be combined. They will be merged. No? So you will have both different patterns plus the overwritten pattern from the left one, no? From the right one, sorry. And then you just keep putting that. And there's a shortcut for that, which is this greater than, sorry, well, I don't know which is which, but. And then this gave me the idea that I could use it in a modular system. I could make atoms of musical ideas or musical expressions or musical attributes that I usually use, like I don't know, in music notation, there's the piano, the mezzo piano, the pianissimo, forte, blah, blah, blah. And they expressed with P, 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 or F, 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 F. So I just mapped that to a variable, and it's just a p-bind with one parameter. Same for panning, for speed, for whatever. You can put anything in there. Oh, sorry about that. And then when I wanted to play it, I could put it in a pdef inside a ppar, which is just an array to play parallel patterns. And this way I could make like a, I don't know, maybe it was a bit like they were saying in Strudel. You just add stuff together and it affects the one on the left. And you can still use regular SuperCollider code with it, which was one of my objectives. I don't know if this will sound. No, it won't. So I could just take away or put more stuff like these functions. And then I decided to port that into a class, well, to extend the pattern class. And the basic implementation for any pbind would be is I put a method name, whichever I like, which are the ones that are down here. Like it's the same idea as before, but as a method. And then using a pchain with a new value, but with a previous pchain, no? Or a previous pattern, so they would be added to it. And then I return that pchain. This way, I can get a dotted notation like in Strudel, and we'll see that shortly. Okay, so no. So this is the same. This would be the equivalent of the previous example with a chain short syntax, but in Živa. And first, I would set up a pbind. This is just a shortcut for a pbind with an instrument called acid, and a psample, which loads a special event that I also created for Živa to load the samples and handle them like in SuperDirt with the N and the sound name and everything. And then this is still in a pdef. And this is the exact same example as before, or maybe not the exact one, but it's the same idea. But using the method composition notation. Let's see if it sounds. So yeah, it's the same. And then there's more or less the same idea with data patterns. In SuperCollider, there's two kinds of patterns, data and events. The data patterns, you pass them into event patterns so they can be played. So one is the score and the other one is the player, more or less. And I did the same with patterns, with data patterns, so I could get the same notation from arrays, and everything would get more or less consistent. These are the examples of the equivalences between the custom patterns and the pbind. And this is how a full performance would look like. First, we boot the server, then we load the samples, we prepare some noises, and then we play them. And this array is also a shortcut for the pdef, ppar, blah, blah, blah. It's called just Živa. I could put here pdef, Živa, quant, 1, and it's the same.
Thank you, Roger, for sharing your language and the journey that led there, which I guess might seem familiar to many of us. So now we have room for questions, answers. I hope anyone has questions, so I don't need to come up with one. Does anybody have a question? You do.
I have a question about Strudel. How do you load the samples? Oh, there we are. How do you load the samples into the browser?
So you either can load the samples from some URL and create a little object from a mapping from sound name to URL of a WAV or MP3 file or whatever you can load with the browser, or you run a local file server and reference the URL from the local host or whatever. Yeah. And you can also view the sounds in the bottom tab, but yeah, I haven't showed that.
Cool. That's anything else? Yes. Maybe come to the front. We just have a cable, so.
Yeah, this is also a question about Strudel. What scheduler did you use? Like, how's the timing? Because this is always a problem with patterns, and even SuperCollider, even Max. I mean, timing is always, to me, yeah. So I was curious.
Yeah, it was a custom-built scheduler. In the beginning, we used Tone.js for scheduling and also for audio, but it has some limits. And if you do dynamic things like firing different cutoff values in parallel, you always have to create a new instrument, so it was bad. And then I implemented a custom scheduler using the Web Audio API with set interval. And but it's not just a set interval. It's I actually wrote a blog post if you're interested. But yeah, it's a look-ahead scheduling. Tale of two clocks is the keyword here. Yeah.
Yeah, I know. So that sounds very good. I'm happy.
There was another question over there.
This was a question about Strudel again. So you say that some functions were ported from Strudel to tidal cycles. Do you have any examples? Yeah, or particular functions. I'm just curious.
So most functions actually have been ported. There's also in the docs, I think there's a list. Maybe just in the GitHub repo. I don't know exactly where the list is. Somewhere it is. But we actually ported most of the functions, like the fast, slow, the time transformations, and all the control parameters for SuperDirt are there. And yeah, some effects, like 8 to 10 effects or whatever, and not all SuperDirt effects. But yeah, there's also a comparison page between Strudel and tidal functions somewhere. Yeah.
Neat.
So yeah, so from Strudel to tidal, what was there? I think maybe the squeeze was one. Yeah, the direction. So being able to squeeze one pattern into the events of another. Oh yeah, reset and restart. So you can have a binary pattern that resets another pattern, so you can have really flexible, yeah, good for like doing breakbeat stuff where you're constantly resetting. Yeah, can't remember what else. There was some other stuff. Like if you look at the recent additions to tidal, yeah, there was quite a lot. I'll have to double check.
Okay. Anything else?
I actually have a question about sardines, so I'm going to have to make you walk up here. Sorry about that. But just about wondering how quickly you've observed, given that you're trying to create a system that accommodates a bunch of different live coding styles, how quickly have those styles diverged in like a performance setting? If you look at someone using your system, how drastically different is it syntax versus one person to the next?
So about the different syntaxes, when you see people playing with Sardine, sometimes you see tidal nostalgics, so people trying to do like very complex functional patterns. Sometimes you also see people that don't care at all about patterns, and they just want to schedule things in time, like machines and things like this. And Ziffers also encourages you to think about melodies and generative, like whether it is chords or like long melodies. So you will get very different results depending on who's playing, and also, yeah. So it really depends. Like I've seen a few people playing with Sardine, and I've never saw someone playing like me, which is encouraging, I guess. But also like the combination of different pattern languages for the moment is also a way to like basically patch the fact that we don't have like a very deep patterning system, but we have many of them. And so yeah. Okay,
stay here. Oh, yeah. If anybody else has a question to one of the developers.
So my question is also about Sardine. One of the things that I have been really frustrated about using languages that use strings to describe patterns is that you can't really splice code in the strings. But Python has the F strings, so is that something that you've used to sort of change the pattern algorithmically using just standard Python code? And also, since you're using a custom sort of packaged up interpreter Python, are you interested in pushing it beyond the language, like making it incompatible with other Python interpreters by, let's say, adding custom syntax for patterns so that they don't have to be in strings?
So I am exploring different things about this. So like the strings are usually typically just strings. You can use F strings if you want, but there will be a conflict if you use the SPL language, because in the SPL language the curly brackets are chords. But if you are not playing chords, yeah, you can inject Python code into your patterns. But we also have something called the amphibian variables, because we need like fish metaphors. And the amphibian variables are like variables that exist on the Python side, but also exist in the parser. So like you can have a swimming function querying a value somewhere in the outside world and inject it directly in your pattern, which is a cool way. And concerning doing some like patching how the Python code is interpreted, it's not a priority, but it will be nice. Yeah. But it's just that I don't really know how to do it, and it will take time, and yeah. But why not? Yeah.
Okay, anything else? Ian?
Hello. I also had a Sardine question. I saw in the examples in your swimming functions, you can do things like call sleep, and I was wondering how this interacts with like generators or coroutines in Python. There was no await or yield there, so I'm wondering how does that suspend the function?
So the asynchronous part is very complex and weird. Basically, sleep is not sleeping at all. What it does is deferring things later in time. So, for instance, if you sleep for a very long time, it can like basically play a long time after your function. So if you like delay sleep for one day later outside the function, when everything will have stopped, you will have the sound coming, which is funny. And also like basically you don't see any await, you don't see any declaration like any async code, because everything is asynchronous. We use like There is an hidden feature in Python, which is like if you can start the interpreter by typing Python, but you can also start it by typing Python module async IO, and it will start a very special interpreter. And we have been patching this one to make it like, so yeah, if you look in at the Sardine code base, especially we have a very frightening file called asynchronous, and the asynchronous are basically what happens when a function is being transformed into an asynchronous function. And basically, there is an idea of sort of lifetime of the function when it enters the async system, when it leaves the async system. But it's a bit hard to grasp, even for myself, I would say. Yeah, we've been working on it with another developer from Canada called Juan. The game cracks is his name. So yeah, the best answer I can give you is deep dive into the code base. I can help you. I can pinpoint the different parts. But yeah, the model is weird. Yeah.
Okay, we slowly have to wrap up. We have 6 more minutes. Anything else? If not, yep, go ahead. What we're here for.
I also had a Strudel question. Yeah, I was curious. I saw you mentioned in future work wanting to have block-based evaluation and support for live collaboration. I've tried fiddling around with Strudel, like in Flock a bit, and I was wondering. So in Tidal you have like D1, D2, all of these things, and so if you're like playing with someone in Troop, you can just divide it up. And I'm curious. Do you think something like that would be appropriate for Strudel also for live collaboration, or how do you think that might fit so you can like sort of work independently but in the same environment as well?
So yeah, there are basically 2 models for collaboration. The one is the Flock model where you have multiple inputs, and the one where you have one input like Troop. And when you have the block-based evaluation, you can do the latter, so in one input. If you don't have it, it's bad because when someone else writes and you evaluate, then you evaluate the invalid code and it doesn't work. So if you want that, you need some kind of fine-grained evaluation, yeah. And that would be cool to have for that purpose. But in Flock it already works without it because they're one input for one person. Yeah.
Okay, maybe just to wrap things up, we have seen different approaches, different trends in language design, the overall threads, abstraction, paths to abstraction, patterns, which seems to be a big read thread, porting stuff to the web and polyglot environments. Any estimate where it will go in the future or what will come next? Well, then we can leave that open and wrap it up for this first session. And we have a little break, a little bit longer than expected. Grab a coffee and be here for the next one, which will be about art practice, how to integrate live coding into art practice and things around that. So see you back here at, I would have to look at the schedule, but you can do that yourself. So see you in a few minutes.
need Wi-Fi because some of my content's online.
Please remember which one. It's obvious, but which one you use.
Audio? Really back somewhere? That's me. No, that's not really Nearly. I'll have made it once the projector is hooked up and everything's working, and I'll have made it.
I see that you're connected, so.
I just don't know the sound.
Okay, audio. Wi-Fi?
Yeah, I have Wi-Fi.
Okay, then you're all settled?
I guess I am. Yeah. All right, good. Ha-da-da. Here we go.
Yeah, this is. I have an adapter, but then we have to show it. It's no problem. Yeah, we just. It's good to check. Yeah, ideally yes. Yeah.
Okay, good.
So we're gonna unplug for a second.
Sure
check
thing.
hers.
Yeah. Okay.
And then plug it back.
Right. Okay. Good.
It should be all
go for
good.
it. Fine.
Yeah. Okay. Yeah, it's previewing there, otherwise everyone sees. So I walk. So if you can give me some sound and image, then I walk to the computer, check if it's alright, tell you if it's good, and then you just say.
Okay, let me know when you want to hear sound.
Do you want want to put that up there for a second? Go
Yeah,
on,
that
make
would be
yourself
great, actually, thank you.
It's
Sorry.
busy, isn't it?
Yes, we met
met
before.
in court briefly.
Yes, we did, yeah.
Yeah,
How
we
you doing?
did. I'm doing fine.
Nice to see you again.
Yeah, exactly.
Yeah.
Nice to have the whole community
I
together.
know, it's always so nice to come to these things and then you like see them.
Yeah, exactly.
Yeah.
People you only know online because of some
Exactly. Like
some handle they've got.
Yeah, exactly. You're like, oh, you're
Oh, you're so
1, 2, 3. Yeah. Okay. Okay. Cool. Do you want to set up the Yes, we're all good.
You're good, so we can unplug this again, give it to him, and then...
Perfect.
Yeah.
Thank you.
Yeah, you're welcome. Yeah, it's yours again. Yeah.
Good.
Yeah, it's...
Okay, right, good. The only thing is, am I going to be able to read from this okay?
Ivan, pass, come to the podium, please. Ivan, pass, please. It's not around.
No. Okay, how are we going? Is that going to work? Sort of. Okay. What else have I got open here that I don't need to have open? Nothing. I should rotate off. My name is test check 1, 2, 3. That's quite a nice slide.
The order is. Hello. Yes.
I'm here.
You
On time.
You
I'm
made
here.
it. You were already there.
I made it.
Listening,
Yeah.
Listening to the presentation.
Yeah, I was fine in there. Yeah.
Nice.
It's not a rude question, but we'll say the name, say the J in your name.
Oh, well, you see, you could go for very Vanderwall, you see. Or you could go Dutch if you want. If you want it authentic, you could go Afrikaans. Okay. I'm a Simon van der Vat. I'm a Simon van der Vat. That'll be South Africa.
It's like a
Just say Vanderwall. Vanderwall. What does it mean?
I would say fun.
Fun? Well, it's Van der Vat.
Van der Vat.
Do you pronounce the J in the...
This J.
Dr. J. Simon van der Vat. Master of everything.
Yes, that's the...
You call me, that's what
That's the... And if you add the doctor at
the doctor,
before,
yes,
it's like
yes.
even...
I like Germany. Herr Doctor Professor.
Yes. It's even
more.
Even
yes.
more evil.
Yes.
You add some evilness to your...
Yeah.
And doctor...
So second up is Elizabeth over there.
Elizabeth?
And third is the guy in the back with the curly hair. Just to be brief.
Felipe, McLean.
Exactly.
Okay. So you know how it works, no? Basically? You have 20 minutes each.
Yeah. I think everybody is here for the first session.
So Simon... Hello everyone. We are about to start with the second paper session of this ICLC 2023. Please take your seats. Fasten your seat belts. Okay, so I'm going. We have 3 papers for this second session. One is Floating Gold, an international collaboration through Estuary that is going to be presented by Simon, which is over there. Then we will have MosAIck, staging contemporary AI performance, some reflections on connecting live coding, e-textiles, and movement, which is going to be presented by Lizzie. And finally, we have another interesting paper called Be Briefed, Convergences and Possibilities of Live Coding and SuperCollider Tweeting, which is going to be presented by Felipe. So, we didn't hit, yeah, yes, because you're arriving late. So, three papers that are asking for me to present it again. So, Floating Gold, an international collaboration through Estuary, that is going to be presented by Simon over here. Then we will have MosAIck, staging contemporary AI performance reflections on connecting live coding, e-textile, and movement, presented by Lizzie. And finally, Be Brief, some convergences and possibilities of live coding and SuperCollider tweeting, that is going to be presented by Felipe. So without any further introductions, welcome again. And Simon, the stage is yours.
Thank you. And my slides are about to appear. Maybe. Come on, I spent hours on these slides. There's my slides. Hello, hi. Hello, everyone. My name is Dr. J. Simon Vanderbilt from the Royal Conservatoire of Scotland, known to people online as Ted the Trumpet. But I'm not really here in either of those capacities today. I'm here to present the Floating Gold project, which is a collaboration between Nagamas, the Glasgow Gamelan group, and 2 Indonesian artists, Peni Rini and Rangga Purnama Aji. None of these people are here today, but I think some of these people, depending if they've got up at 5 o'clock in the morning, might be watching along on YouTube. And the relevance of the project to ICLC, of course, is the central role that Mini Tidal and Estuary have played in this project. The paper itself was distributed this morning. I doubt if anyone's had time to read it. I'm not going to literally read the paper out. Thank goodness. Oh, okay. I'm going to talk around and about the project and show some of the bits of documentation, so there's more detail in the paper. And the other thing is I'm going to talk more holistically about the project, and because most of the people in this room probably know a lot about code and Tidal and Estuary, I'm not going to concentrate on that, but more on the collaborative musical and aesthetic aspects of the project. Okay, so to begin at the beginning, who are Gamelan Nagamas, and indeed, what is gamelan? That's the wrong slide, there we are. Here's a little clip of us at a recent sharing session at our rehearsal space in Glasgow. This is just the very end of us playing a simplified beginner's version of a piece called Lancaran by Torkandas. Javanese gamelan players in the room? Good, so nobody spotted the deliberate mistake by the canon player, right? That's okay, that's fine, good. We are a community group that was established in Glasgow around 1993 at the time that a set of central Javanese instruments was purchased for the city by a consortium between the Regional Council and the Scottish Chamber Orchestra. I stress here that that was a central Javanese gamelan. One of the problems in talking about gamelan to a non-specialist audience is it's a little bit like talking about African music. Gamelan music is not a single thing, but encompasses a wide variety of different geographically, historically, and culturally located practices played on different kinds of instruments. I've represented them here, three. The bottom right-hand corner is one of the best known, that's Balinese Dong Kebyar. Less well known in the West is Gamelan's Sunda Degung. Not a lot of people know this, but the gamelan that Debussy heard was actually a Sundanese gamelan, not a Javanese gamelan. And at the top there, we have a Javanese gamelan. The thing at the top there is actually a video, so I'm going to play a little bit of that just now. I chose that particular clip for two reasons. First of all, the singer there is one of our Indonesian collaborators, Peni Chandra Rini, here in a very classical setting as a Sindan, the classical female voice in Central Javanese gamelan. But the other reason for picking that particular clip is to stress the importance of singing and the voice to Central Javanese gamelan. And I specifically edited out that segment so you could hear both the female vocal and a bit of the male vocal, the gerong. Manis rengoku samane. I don't believe I just sung in Javanese to the entire internet. So anyway, that's a bit about what is gamelan. How did a community gamelan group end up to be involved in live coding? So in March 2020, like musical ensembles all over the world, we found ourselves unable to play music together as a result of COVID-19. And again, like musicians all over the world, we had a go at playing together over Zoom, which didn't work very well because of latency and poor sound quality. And we also did this thing here. We lent people individual instruments and took them to their home to see if we could try playing them over Zoom. But it wasn't really very successful. So we were looking for something else to do together online to keep the group alive. As someone with an existing live coding practice, I had an idea, possibly a crazy idea. Maybe we could play something in the nature and the spirit of gamelan music together online in Estuary. So, to pursue this idea, I worked with David Ogborn at the Network Imagination Laboratory to upload a set of samples created from recordings of the Spirit of Hope gamelan instruments in Glasgow. These have since been updated several times as the project grew and developed, and you can play them in Estuary if you want to. I also created a set of video tutorials for the group based heavily on Alex McLean's Learning Tidal Cycle course, thank you Alex, which you can see here, a combination of code samples and Google Docs and some talking head videos that I made. So armed with these samples and the tutorials, I set about teaching the group how to code in Estuary. This was partially successful. Not everyone in the gamelan group chose to take part. From a regular attendance at around 15 people at rehearsals, the live coding group dwindled to just 7. But that group were very keen, and we did manage to learn enough about the mini-tidal syntax with our gamelan sounds to produce some interesting improvisations. During COVID, the group did 2 online performances at the Network Music Festival in July 2020, followed in December 2020 by the Waves project, a performance based around the composition Waves by group member Margaret Smith. Here's a little clip of that. In this performance here, we were combining a bit of live Zoom video with the Estuary. There's a place in that where I'm actually playing a gamelan instrument live from my bedroom, but you don't actually get to see that bit there. Now, this person here on the slide is in fact Heather Stroschein, one of the co-authors of this paper, and a long-time member of Gamelan Nagamas. A lot of her PhD is actually about Gamelan Nagamas. And he's actually, in fact, currently the convener of Gamelan Nagamas, who lives in Bowling Green, Ohio, and we're in Glasgow. So she has taken part in all of our live coding projects remotely from the USA. And this realization that the Estuary program platform allows for musical synchrony no matter where in the world people are located is what led to the idea of collaborating with Indonesian musicians. Thanks to my own involvement with the live coding community, I was already aware of the work of Rangga Purnama Aji. Again, I'm sure many people in this room have played with Rangga. This shows his entry in the recently published live coding user's manual. I'm not sure what time of night it is in Indonesia, but Rangga, if you're listening, hi. So Rangga is a composer, electronic musician, songwriter, live coder, and digital artist, and one of the originators of the collective Paguyuban Algarve Indonesia, the Indonesian Algarve Association. We approached Rangga in particular because we were aware of an explicit gamelan influence in some of his work, which is evident in a couple of his online album releases. So I've already played that clip of Peni Rini singing in a traditional Javanese style. In fact, Peni is one of the foremost composers and creative performers of contemporary gamelan music working in Indonesia today, in Indonesia internationally, in fact. Gamelan Nagamas were fortunate to have had the opportunity to work with Peni at the Festival of Gamelan and the Moving Image at the Royal Conservatoire of Scotland in 2017. As you can see pictured bottom right there. And we were very keen to see we would have an opportunity to work with her again. When I first approached Peni, I had the vague idea that she might be interested in coding herself. But that's not the way it turned out. What Peni wanted to do was sing. And this brings us again to the central importance of singing to Central Javanese gamelan. So as a way into this, I'm going to play the first minute or so of the first video work that we completed together, entitled Mas Kumambang. And I'm going to play this on YouTube because it's got the subtitles if I play it on YouTube. So just a couple of minutes of this one here. Okay. Let's get that going. So that first work of ours, Mas Kumambang, is in many ways the artistic and thematic key to the whole project. Mas Kumambang translates from the Javanese as floating gold or gold floating. And Peni explained to us that one of the ideas lying behind the phrase Mas Kumambang, floating gold, is the child floating in the amniotic fluid in the womb. Peni is herself a mother, and motherhood became one of the themes which we employed in later works of the series, including Ibu Bumi, Mother Earth, which is on the video display as part of ICLC, Pari, Rice, where Peni's lyric begins, Aku Ibu Pari, I am the rice mother. The phrase floating gold was also the inspiration for another member in our group, Kath Wormsley, to do a piece of creative writing that drew upon the myth of St. Tanu, a pregnant woman cast into the sea by her family to die, who is rescued by the fish and then goes on to give birth to St. Mungo, the founder and patron saint of the city of Glasgow. The ocean appears in an element of several of the video pieces we made up, including Lautan Ocean and Wele Sano Have Mercy. Going back to Maskumambang, I've dug into some of the documentation I kept of the project to show some of our working methods. In the following video clip, you can see the coding members of Nagamas, together with Ranga, taking turns to improvise a code roulette in Estuary, while overlaying Peni singing along on Zoom. While this was fine for trying ideas out, we were not comfortable with either the sound quality or the image, and of course the latency is quite significant. Instead of attempting to work purely synchronously, we evolved a way of working where we would screen record code improvisations in OBS, sometimes with Peni singing along, sometimes not. We would then typically find 4 to 7 minute excerpts from long improvisations that appear to be musically coherent and send the audio on into Peni in Indonesia. Peni then drew on a large team of people that she works with in Indonesia to produce a series of beautifully costumed, lit, and performed video pieces with her singing along to the pre-recorded music. I should mention at this point probably that all of this was supported by a grant from the British Council, which made it possible for us to have the camera crew in Indonesia. So those videos were then sent back to Scotland, where I had the job of overlaying the original code improvisations and synchronising them up. There's a couple of slides here I think I'm going to skip for keeping to time. This was just some documentation of how we actually layered the things up and what the things finally looked at. So from the perspective of the audience, there's a certain amount of trickery going on in the 8 final videos because the impression might be given that the whole thing was being done synchronously. However, in a second stage of the project, we did, in fact, find a way to perform together at the same time. Hang on, drink of water. It's amazing how nerve-wracking this is. Right, okay. Yeah, there was a very elaborate setup whereby we had Peni and Ranga in the palace with the king in Solo, and they had a live gamelan, all of Peni's students. So they were performing there, then they were streaming the Estuary, and the Estuary was being played in Indonesia, while we were performing the Estuary code and listening to a stream of what they were doing and then attempting to synchronize the whole thing. We had no idea what it actually sounded like in Indonesia, but apparently it went really, really well. So that was us doing one synchronous event. So this Friday here at the Immersed in Code concert, we're going to try and do something a little bit like that again. We're revisiting a piece called Vortex Resik. Ranga wrote a set of graphical scores with instructions, and this is the one we're going to be playing there. You'll see it at the weekend. It's a combination of Peni singing, which gives us cues to change some title code with a free improvisation at the end. So for this performance on Friday, Peni is going to be joining us synchronously from a residency she's on in Richmond, Virginia, together with coders in Glasgow, Ohio, Jakarta, and of course me here in Utrecht. Okay, I don't know how I'm doing for time, but I'm getting my conclusions. Okay. It's fair to say, 2 minutes, perfect, look at that. What a professional. It's fair to say that we exceeded our expectations in this project. At the start, we envisaged something much more modest, perhaps a screen grab of some code in Estuary with a small inset video of Peni singing over Zoom. We didn't know Peni was going to make those amazing videos, and it completely transformed what the project was. It's remarkable to me how successful the combination of Mini-Tidal and the Estuary platform have been in enabling remote international musicking in the context of gamelan. None of the members of the group, apart from Ranga and me, have any background in coding. I don't even have a proper background in coding. We were literally starting out with things like the difference between brackets, braces, and parentheses, and where do I find that funny squiggly thing on my keyboard? And as there's a lot of people here in the room, I'd just really like to thank the developers of these tools for making these things free and open source for musicians like ourselves to use. So, finally, as musicians, the best outcome has been to affirm the strength and depth of, in its broadest sense, gamelan. To discover that the philosophies and practices that underpin Javanese music are strong enough to support and inform music made both live in a room with instruments and through a remote collaboration through the medium of live coding. Thank you very much.
Lizzie, whenever you're ready. Thank you, Simon.
Thank you. Cheers.
Perfect.
Sorry. Do this. Yeah, I'm trying to get the to stop mirroring from this display so we can see the presenter notes.
Presenting, and you have to be able to see that. No?
Yeah.
Okay, I don't know if it was configured. Let me see. You should be able to try to connect it again.
Mm.
If not, let us then reset it.
Okay. Okay, so if I do this.
You should there, and then full screen.
Yes, there we go. Okay. Perfect, got it. Yeah, okay, thank you.
Live coding projectors.
Yeah. Okay, hi everyone. Sorry about that. So I'm here to talk about a project called MosAIck. So we were looking at staging contemporary AI performance. So for this project, we had an interdisciplinary group of artists who came together to host a series of performative rituals that explore the neo-esoteric nature of artificial intelligence in contemporary culture. So we're using a network of live coding and performance and sensing to invoke a sensory intelligence through a series of rhythmic rituals. So we're joining together improvised codes of sound and dance and textiles to form a kind of collective network. So we were a diverse team of people with kind of a lot of different backgrounds, from e-Textiles over here, so people working on costume and interactive design, obviously some live coders up here, and some performance artists as well. So we were all united by this project, which was the Link Masters grant, and supported by the Lower Saxony Foundation in Germany and Leonardo. And this particular grant was really developed to explore different ranges of projects within AI in the cultural sector, and seeing how the cultural scene could benefit from these results. So kind of one of our main goals for this project was to kind of challenge this dualist thinking of mind and body, and open ourselves to a more kind of human-centric approach to AI in terms of things like pattern generation, pattern recognition, and connectedness, but also things like resonance, textility, and spirituality as well. So these were kind of realized with performances that kind of united all of our collective practices, and kind of created a ritual which explored some of the following themes. So there were 2 performances of this ritual that occurred. So the first occurred in Sheffield as part of No Bounds Festival in October 2022, and then more recently in Transmedia Studios in Berlin in March 2023. The second performance was actually kind of outside the scope of when we wrote this paper, but I'll be sharing some of the documentation of this as well, because it was kind of an extension of this project. So really the project was kind of inspired by lots of different things, but one of them was this quote from Deleuze and Guattari, so saying, "Rhythm is the milieu's answer to chaos. What chaos and rhythm have in common is the in-between, between 2 milieus, rhythm, chaos, or the chaosmos. Between night and day, between that which is constructed and that which grows naturally, between mutations from the inorganic to the organic, from plant to animal, from animal to humankind, yet without this series constituting a progression." So the project aim was to really look at this alternative, non-hegemonic view of intelligence through this creation of the performative ritual. So instead of considering an algorithm, a dance, a textile circuit as intelligent, we were looking for the kind of intelligence between these elements. And we know that AI often tends to kind of simulate and reproduce the functioning of the human brain. So hence our kind of understanding of intelligence is built on this metaphorical understanding of the brain. But our idea of how human cognition has worked has really kind of changed over time. And scientific and technological developments have all been really critical to our kind of contemporary self-understanding. And kind of this maps as, you know, philosophers and scientists attempt to understand how these innovations in computing are actually mapped into human intelligence. So there's also, this project was inspired by a work, Rhythms of the Brain by Georgi Buzaski, where different parts of the brain are kind of brought together in a whole network in mutual oscillation. And kind of considering Clarke's embodied and extended mind hypothesis, we focus on kind of feedback loops between perception and action as the base of intelligence. So also kind of following James Bridle's work in New Dark Age, if anyone's read it, we were kind of thinking about intelligence in terms of other intelligences. So, you know, rather than the popular definitions that, you know, reproduce this dualistic interpretation based on rationality, we were kind of approaching the creation of collective intelligence through this practice of improvisation. So kind of creating an assemblage of lots of different human and non-human aspects. So kind of creating of this ritual, we were thinking about, you know, maybe the kind of beginning of the 19th century, we saw, you know, all these advancements in science and technology really kind of provoked an interest in these mystical practices of rituals and spirituality. Our kind of contemporary relationship with mediating intelligence has also kind of led us to explore these kind of more esoteric practices, which, you know, as a way to kind of decipher wider meaning from our developments in AI. A lot of people kind of turn to AI in almost a monotheistic way, asking it questions about, you know, the origins of the universe to DALL-E. And and kind of musing on AI kind of really resonates with this kind of Western monotheistic cultural practice. So kind of our aim was to kind of create a new perspective on our relationship with technology. So turning it away from this kind of singular noun variant of an AI into its counterpoint of just artificial intelligence. So kind of this intelligence wouldn't be centered in a small plastic case like Alexa. It would be kind of a human or an animal body, but something kind of distributed across many things. And these were kind of a lot of the kind of suggested texts that we read when we were kind of thinking about establishing ritual as a framework. But to kind of discuss how we achieved the aims of this project, we kind of initiate how we kind of constructed this using our existing technological practices to kind of interface between the e-Textile components with the kind of computer technologies, such as kind of live coding and neural networks, which we would allow then the performers to interact with. So kind of throughout this project, we've really been jumping between imagining rituals and creating technical systems, and it's not always clear which is which. So, you know, for example, as collaborating e-Textile, live coding, and performance artists, you know, working together allowed us, you know, really required us to establish meaningful data flows and protocols for collaboration, which we could also kind of characterize as channeling, channels for carrying resonance between us. So, in terms of technology, here we can see a bit of the data flow that occurred when we were constructing a performance for Sheffield in October 2022. So at the exposition of the piece, we had data from sensors on the face at the top, and these were sent from the performer to the computer systems using the ZMQ or 0.MQ protocol, which is kind of similar to kind of OSC as a kind of communication protocol. And in this, the kind of sensor output was thresholded so that the movement of opening and closing the mouth would lead to different sounds being triggered. But the sounds that were being triggered were actually made using an artificial voice. And this would kind of create a set of words that were kind of nonsensical words from our artificial voice, but through their kind of repetition and cycling, we kind of gave the impression of counting sequences. And to kind of create these sounds, we used a neural audio synthesis model called RAVE, which is for those who are kind of familiar, it's a variational autoencoder model, which has been adapted for use in real time. And it allowed us to do a process called timbre transfer, which is basically, for people who are familiar with machine learning, it's an interpolation of a latent space based on some input sounds. So these could either be audio files, but it could also be live input from a microphone. So we had the live voice of one of our performers being mutated by this artificial voice in real time. And then alongside this kind of neural audio synthesis part, there was also live coding and tidal cycles, where the live coding was also shaped by the interaction with the textiles. So the kind of performers would interact with some conductive textiles that were created, and this would send data into tidal cycles using the ZMQ protocol, and allowed us as live coders to kind of work with the interaction that was happening from the performers as well. So a bit about the e-Textiles. E-Textiles are kind of create soft and flexible sensors that were worn on the body to sense the body movements. And for this performance, we explored e-Textile pressure sensors made of EonTex stretch-resistant fabric, which kind of sense bend and stretch of garments by body movements. And we used a Bella Mini board, for those familiar. It's like a microprocessing board, which allowed us to read 8 analog sensors. So firstly, we used that to obviously directly trigger the sound from the face, as I just talked about. So this is an example of a pressure sensor made using kinesiology tape to detect this kind of face and mouth movement. And this would kind of change the parameters of the voice that was coming out. And secondly, we used the Bella board to process the multiple sensor data coming from these kind of fabric suits. And we used something called MLlib on Pure Data software for Bella, which is a kind of gesture recognition toolkit developed by Nick Gillian. And the proposed functions of that are kind of very similar to Wekinator for people who are familiar with that software. So it allowed us to kind of classify some of the movements of the performers into smaller dimensions. And then the e-Textile kind of sensors placed on the bodies to capture precise movements were enabling our system to kind of recognize the repetitions in the movement. So for how these performers, these sensors kind of create this notion of activation points, which tend to become unwanted frameworks when choreographing new movements. But the most interesting performative movement really happened when the performer became familiar with the system and kind of really had their own understanding of how movement would affect the outcome. So, started to try and work beyond the limitations of strict choreographic rule sets. So, in other words, they were kind of in a flow with their own kind of creative act. So here are some of the final kind of the final textiles that we developed. These were the ones that were shown in Berlin, which were made using a jacquard weaving process. And we were taking some images from prompts in disco diffusion and then actually weaving them into textile. And here we can kind of see a bit closer up. So each printed textile had copper thread embedded into it. So these were kind of included into the weft every 3 millimeters. So I'm not that familiar with e-Textiles, but for anyone who is, this was the kind of process that we were using. And this allowed us to kind of create 30 sensing points. And here's the Bella trill board that we were using to obtain this data. And this was then sent on to us as live coders as well. So Tidal Cycles was the software that we were using for live coding sounds, but we kind of employed a few kind of our own custom elements within the performance to kind of alter the territories that live coders are used to and really pushing them into new ways of interacting with sound through software. So the two live coders were Alex and myself, and we were tasked with kind of independently working with this kind of sensorial information, but then also kind of collaboratively with each other. So we were kind of responding to each other in the performance as well as responding to the performers. So in the prototype in Sheffield, we worked with sensor data from the fabric in these conductive threads, and these were really manipulated to alter the live coder's music. So two of the main strategies for this, the first of this was this kind of code setup where we were using different areas of the conductive thread to actually trigger different patterns that we'd already constructed. So thresholding the data so that it would understand when a touch was received in different parts of the textile, and then the patterns would play. And then the other kind of methodology that was often used was kind of using this reduced dimensionality of the MLlib to kind of create smaller dimensions of data, and then these are used to kind of control the effects. So, for example, here we have, say, like a DJ filter effect, and then this here is the data coming in from the textile, so we're kind of mapping it to control this filter effect. Or the same with kind of logarithmically applying to the gain, so that these, when the kind of interaction happened, it would shape the live code itself. So it's probably easiest to see some of this as well. So that was one of our performers, Deva. She was just kind of warping the sounds through her touch, but that was really affecting the code that was happening as well. And then here we have an example of what I was talking about earlier, where We had the artificial voice. This was kind of a further iteration where we actually decided to use the movement of the body to kind of control the artificial voice, and really allow them to kind of explore these kind of unfamiliar sonic territories of something that is usually familiarized, which is their own voice. So here the kind of sensor pants that this performer is wearing are kind of recognizing the patterns of particular poses and then using that to interpolate the latent space. So it was pretty fun to work with. So we were kind of, thinking more generally as well, as we're working for this call for AI in the creative practices, how can we incorporate AI in our kind of collaborative works? And we discussed, whether to treat it as a tool or a subject matter. And very briefly, I'd say, it's a difficult subject matter. People have kind of certain expectations of what, AI, and if you don't want to fake the technology. And then AI is kind of really accessible for creative coders, it's limited. People kind of expect some stage magic. And we kind of really had to fight this distinction between, live composition and audience attention and engagement. So I'll end maybe with this trailer. This is the second revision of the piece in Berlin. Cool, thank you.
So last presentation is called Be Brief, Convergences and Possibilities of Live Coding and SuperCollider Tweeting, presented by Felipe Martins.
Okay, so hello everyone. It's a pleasure to be here today. I am a PhD candidate at UFMG. Unfortunately, José Padovani is at Brazil now, so maybe he's online, so hi to him as well. So, in 2009, Professor Dan Stoll, who is an academic researcher and SuperCollider developer, began posting on Twitter fully functional SuperCollider code within the constraint of 140 character limit. The tweets got the attention of the community and rapidly several people engaged in posting dense and intricate SuperCollider code at this microblogging platform. This communal atmosphere eventually led to the compilation of tweets into an album, SC140. Unfortunately, nowadays, Twitter is being transformed into something utterly different from its original shape, and many people are kind of abandoning the platform. The term live coding, on the other hand, covers a broad range of practices, as we can easily see in the current conference. But, okay, thanks. But with a common underpinning, which is the necessity of interfacing with a programming language that allows easy and fast typing for complex tasks. We aim to investigate the tensions and frictions between these practices and explore how the unique characteristics of each can add the other. The objective is to bring together these two constraint-based creative approaches to computer music: live coding, which we will call LC, and SCTweeting, which we will call SCT, and to conceptualize, compare, and contextualize their potential artistic and conceptual conceptions. So, SCTweeting is rooting in a longer-term practice in computing cycles called code golfing, which can be seen as a game/competition/recreational activity where the participants strive to solve computer problems using the shortest source code possible. This communitarian practice gave birth to complex imaginative results that would barely be possible to come out of a traditional programming industry fields. For instance, compiler bombs, tweetable mathematical arts, and make your language unusable. Code golfing, a practice implicating the optimization of code for the shortest possible length, often involves using esoteric programming languages, obfuscation techniques, minification, retrocomputing, software art, and computer humor. This results in disregarding the traditional computer science principles and industry standards in favor of code that creates a mind-bending experience for the user. In this context, users become innovators who challenge machine paradigms. Programming languages become nonsensical collections of characters. Programs become open-ended executions. Ultimately, the capitalist idea of functionality disappears in favor of a non-definable use of the device. It is important to point out some similarities with live coding community and practices. For most recent computer music programming languages like Max, Pure Data, and SuperCollider were not initially meant to be used on the flight, but to be used for live music with real-time capabilities. The possibilities of programming while the program runs is a side effect that users turned into a new artistic practice. We quote Nick Collins et al. In some computer music software, such as Max and Pure Data, we can still see the remnants of the separation between edit and run modes. In SuperCollider, there is the need to manually initiate the run action. When coding happens as an artistic performance, it subverts the typical design goals of computer music software, pushing it to provide new tools for this scenario. Live coding performance, for instance, often requires more than a basic terminal interface with real-time capabilities. It is common to see the use of ASCII art, vintage computer visuals, and character-based graphical user interfaces to create a more interactive and engaging coding experience. These efforts aim to bring a more lively aspect both to the act of coding and to the traditional minimalistic coding screen. We would like to show also two examples of this practice. For instance, one performance of live coding called Screen Bashing by Magno Kaliman, where multiple windows of processor-heavy programs displaying ASCII animations runs until the laptop battery drains completely. And Juan Romero, aka Hucano, where the SuperCollider class library is swept sonically, no matter what can happen to the server or the ears of the curious player. In both examples, we see some influence of industrial software testing concepts like unit testing and stress and benchmark testing, however, intentionally decoupled from its innermost safety procedures or testing metrics. Code lines in both practices do not just serve as a mere record of ideas or as the source code from which an application will be built or evaluated. When displayed during a performance or shared on a social media, this concise series of characters not only generate sounds and images, but also perform the artistic, technological, and social act that define them as practices of live coding or SCTweeting. One essential point for enhancing this performative aspect in both practices is the coder's proficiency. In live coding, the coder's ability to efficiently communicate with the computer through code is crucial for successful improvisation and to prevent potential errors. In SCT, the use of concise and efficient code is necessary to work within the character length limitations. In either cases, a common challenge stands out: to concisely express and elaborate creative ideas. Unlike other computer music creation practice that rely on programming languages, the lines of code explored in algorithms or microblogging social networks must be concise, aesthetically pleasing, and effective, generating appealing sounds and or images. In this context, computer languages serve not only as a means of accessing the coder's idea and creative strategies, but they also take on a structuring and literary role in a similar fashion to that which natural languages play in genres such as haikus, tankas, epigrams, aphorisms, and limericks. Coders often develop their own lyrical style through the use of these resources, which can be heard or seen in the resulting sounds and visuals, but that also can be read as rhymes and assonances, regular patterns of code, recurrent parameters and variable values, recursions, and other repeating strategies that might serve as a recurring theme or as a technique to save and reduce coding time and code length. So, live coding and SuperCollider tweeting approach technology in a different manner from traditional engineering standpoints. They prioritize the creative process and experimental approach over pragmatic functionality. This approach can benefit from concepts and theoretical elaborations from fields such as cybernetics and science and technology studies. The cybernetic concepts of feedback loops and chains of feedbacks by Norbert Wiener highlights aspects of LC and SCT creative process and the connections between humans and the technological tools at stake. The tools, in our case, include not only computers and electronic devices, but also software, operating systems, programming languages, etc. The human-machine entity structures feedback process while conceptualizing notating code, while running the computational processes, projecting or sharing the results in the environment, and perceiving the sensory and social reverberations of his activities. The multiple outputs of the system influence and affect the multiple inputs. The the decision to create a new layer of LC pattern that may interfere with the previous ones, the adjustment of parameters in a SCT generating new unexpected results, new lines received from other codes, recycling ideas from other previously shared. Frederick Olofsson draws the attention to moments while coding SCT when the human mind seems to attempt to emulate a computer and vice versa. Olofsson refers to this as cybernetic music in practice. Blackwell et al. Suggests that the ultimate goal of live coding is to achieve a cybernetic fusion between the human and the machine. They argue that in this integration, the ability to anticipate the mechanisms and results of code is a necessary skill, and that this embodiment of code mechanics and outputs is a key aspect of live coding. Another important concept is Gilbert Simondon isodynamism, which consists of a strong mental connection between the inventor and the machine. Here, the human makes his mind to work like the machine, and the machine to work like one's mind. This process seems to happen on creation, transformation, and projection/sharing of live coding and SCTweeting codes. In the coupling between humans and machines that involve both practices, there is a low level of alienation from coders concerning the technical and digital objects at stake. Even though performing musical live coding and practicing SCT on Twitter do not share any particular apparent purposes, the artistic strategies in use share a common bearing, constraining the use of a tool as a way to propel creativity towards novel artistic solutions. The process of writing the shortest text possible to express one deeply complex idea can be traced back to ancient records and genres of writing like the Japanese haiku, the Greek aphorism, philosophical fragments, etc. However, live coding and SuperCollider tweeting are not only brief, they are built to deal briefly with constraints. This strategy can be related also to 20th century literature movements like the Oulipo. The roots of live writing, or more broadly, lively creation using words and spoken language, can also be traced to ancient forms like medieval troubadour improvisations, like the Brazilian repente declamations and improvisation duos, and the rap battles. Due to its demand for visually appealing text form, live coding approach to displaying text can also be rooted in typewriting art, concrete poetry, and typography, beside the many other types of visually used in performances. In fact, it is important to highlight that artistic practices have used the idea of constraining specific features, deliberately or not, in order to achieve peculiarities in style definition. This seems to be the case here. While SCT is a conscious challenge of finding the shortest syntax that creates a sound piece, live coding does not so deliberately impose. Live coding does not so deliberately impose to its performers the limitation of speed and fluidity which either the language or the coder must have to provide a convincing performance. However, both LC and SCT have been criticized from their resulting limitations. Live coding is often criticizing for sacrificing musical complexity and structure in favor of a fluid coding experience that avoid pre-composed blocks of code. Additionally, live coders and analog synth improvisers are often said to have too many parameters to control simultaneously, leading to a slow evolving performance. SCTweeters, on the other hand, are criticized for lacking musical/sound quality due to their size constraints, such as lack of rhythmic construction in codes with impressive timbres, or lack of interesting timbres when the traditional melodic, harmonic, and rhythmic content is complexly defined. In particular, a point that has been in debate for both LC and SCT is that it provokes the audience an impression that code itself and its ideas is more important than the artistic outcome. The importance of the poetic of the code itself is being raised to a new level with practices like LC and SCT. Often an obscure syntax, superstitious numbers, or hacking style ASCII engage the audience more than the sound itself. However, Nick Collins evaluates that the more profound the live coding is, the more a performer must confront the running algorithmic, and the more significant the intervention in the work, the deeper the coding act. At the same time, it is relevant in the context of SCT. Live coding and SCTweeting were born as attempts of dramatizing and animating a computer algorithm, recontextualizing the place where software was meant to be by means of giving visibility and movement to codes that were designed to be static texts. So that's it. Thanks for listening.
Thank you, Felipe. So we have time for a few questions for any of the presenters. Please ask something so I don't have to come up with. Thank you. And we still have this short cable.
So yeah, I have a question for MosAIck. Okay. It would interest me if you have any experience with how the live coders and the performance interact. Are there communications, talking with each other, or maybe how does the actions of one inform the actions of the other?
Yeah, it's a great question, thanks. I think we try to think of it as like a two-way feedback loop. So obviously we're creating music, so they want to dance to that, but the way that they dance to that then informs the kind of music that we were making. So we were kind of really thinking about how to design this interaction. And one thing that I didn't get a chance to talk about, which we developed it afterwards, was we were looking at kind of interactions with like tempo, so kind of using this pattern recognition to really kind of change the overall feel of the performance. So when they were kind of repeating lots of the same gestures, it would really kind of speed up, and then it would like, you know, if they were doing really like unrepetitive movements, then it would kind of slow down. So we were really trying to kind of think of these new ways of interacting rather than just like, oh, you know, here's your arm bending, we're changing a sound. We wanted to kind of really create these new kind of modalities of interaction between this kind of feedback loop between the performers and the musicians as well.
My question is also for you. So I find really interesting the idea of using the sensor readings to control the code. And one of the main selling points of Bella is how little latency it has when it comes to reading and processing the signals. So did you manage to measure what the total latency was when you added the communication from the Bella to the computer and then into the code, and the whole sort of trip. And also, when you say it was editing the code, was that actually putting in numbers in the code which then had to be sent to the interpreter again, or did the interpreter have like a special hole where the values went in directly? So were you reparsing the code every time a new value was being received by the sensors, or was it just sort of directly plugged in somewhere?
Yeah, thanks. Actually, the latency question is a really good question because in terms of the Bella side, it was great because Bella, for people that don't know, is it's developed for the Beagle board, so it's super low latency compared to like other microprocessors like Arduino. So it allows kind of like audio interactions to have this kind of the low latency, like super impactful feedback. One issue we did have with latency, and we discussed in the paper, was because we were using tidal cycles. Obviously, tidal cycles is based kind of in this kind of repetitive, everything's playing over and over, but when the data would come in, it would be passed in tidal cycles. Correct me if I'm wrong, Alex, here, but it would, before the next event would happen, would be when you'd hear the effect of the data. So actually, you had this kind of interaction where it was being processed as soon as they touched it, but then tidal cycles was kind of waiting for the next step in the sequence to kind of play with this to kind of play this data. So we had to kind of like come up with creative ways to work with this latency. And actually, one of the ways that we did it in, I think, Sheffield Performance was that we would kind of actually work with this latency, and we would say, okay, let's create loads of like feedback loops around themselves, so you kind of actually can't tell, what's happening in terms of the touch. And let's not do this kind of like play a piano thing of like, oh, we touch it and it makes a sound. Let's make kind of more creative interactions that actually work with this latency. And then this was kind of one of the reasons why we ended also developing this tempo thing, because it again allowed us to kind of really work with these new ways of interacting with performers that kind of got around the latency. Maybe Alex can answer the second question better. Is that all right?
Second question.
What was the second question?
Whether the changes for the sensors went into the text and then
no, it didn't go into the text. Control input goes straight into the pattern. Yeah. In Tidal there's quite a lot of latency because it's not so important because you're typing things, and then you don't care so much about latency. But one thing we discussed in the paper was I think the best thing to do is to add more latency to fit the tempo, and then everything's perfectly in time again. Because if you put things into the future is also the same as the past if you think in cycles. And everything's all right in the end.
Thank you.
We have time for a couple of more questions. Come on.
The question's also for you. You actually said that the system you created made an unwanted framework for choreography. And I really want to hear more about what was unwanted.
Yeah, I guess the choreographers would be best to answer this, but from their perspective, I guess as live coders, we were kind of thinking about the task of how do we get people to do movements that will be useful to us. And so we were kind of telling them, repeat moving your leg this way. And I think as a performer, they were really like, I don't want to do that. I want to like dance. I want to do what I do. So we were really having to kind of think about ways that would allow us to capture these kind of interactions and allow us to kind of do something meaningful with them without kind of creating this. And I guess that's what I mean by unwanted framework of like us telling them what's going to be best. They kind of had to tell us, and we had to kind of work with them that kind of inverse way. And I think that was a nice way to collaborate, actually, was to let them do what they wanted to do, and then we kind of build our technology around their kind of choreographic frameworks, I think. Yeah, I also had a question for you. was just wondering how you dealt with the issue of latency, or did you deal with it at all?
Yes. One of the things about the way that the Javanese vocal works is the Sindan vocal is it's very free-flowing over the music. So it's actually almost impossible to write down the rhythm that the Sindan sings in, because all the Sindan has to do is to have a note which eventually is going to land on the seleh note, which is where the music is going to, but it doesn't have to be precisely in time. So there's something about the way the female vocal works which is already comfortable with the idea of synchrony. The piece that we chose to do live synchronously before actually was a piece which it was based on Gaelic psalmody, which has got a form of heterophony, whereby you have a choir all singing. They might be singing the Lord's Prayer in Gaelic, but they purposely don't sing together. Everyone sings in their own time, much as if we all recited the Lord's Prayer here. We wouldn't all be entirely synchronous. So we used that again in the piece. We deliberately made a piece which had, when it's performed live, has a lot of synchrony built into it. And then that meant that it worked quite nicely. For the performance on Friday, there will be however much synchrony, latency there is over the Atlantic. But once again, it's built into the piece that we know that synchrony will, it's kind of part of the piece that we've written there. Yes? Thank you.
Maybe I can read from Fabian's phone really quick, and then sorry. So, question for the session. Here it is. With Floating Gold, to you. Can you talk about the gamelan recordings? How were they created for use in live coding? And how do the performers with traditional live instruments or voice react to the sampled sound in live coding?
Yes. So the samples are pretty simple and basic. I mean, it's me in my bedroom recording the demung, which only has 7 sounds. It goes ding, 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 ding. So they're very, very short and very simple samples. And that's, from a sampling context, that's very limited. I mean, it's not multi-sampling like you have in a proper sample bank. So those samples are quite limited. However, once you do things like a little bit of pitch shifting, for instance, what we very frequently did is, there's a thing in Balinese music which is called ombak, which is where you have 2 pairs of instruments which are purposely tuned a couple of cents apart. So when the 2 instruments play the same melody, you get a chorus effect. You get a beating between the 2 of them. So that was very easy to do in code, and it became one of Aranga's signature methods. So there's quite a lot you can do with sound, even with very basic samples once you start speeding them up or doing some things with them. So the limitation of the sound, I wasn't sure. I mean, the person who was responding as a musician to the sample sounds was primarily Peni, who was a singer. And I think the key to it there is Peni is someone who is generations back trained in Javanese music. So she is very rich and deeply embedded in the full tradition of the music, but is also a very free and creative improviser. And I mean, you can throw Peni into any situation whatsoever, and she will simply sing and work with whatever there was. So she would simply listen to what there was, and she was able to pick up on the sounds that we have and really take the thing off into another dimension. So the fact that from the perspective of a gamelan musician or a musician, the sounds we were using were, well, a primitive approximation of what a gamelan sounds like. By the time we had the whole thing running, there was actually quite a lot we were able to do it. As you'll know when you go and listen to the whole video on YouTube, there's 8 pieces to listen to.
Any more questions? I do have a question for Felipe, and just because I was really I really liked the paper and this how you frame the restrictions of SuperCollider tweeting and live coding, which is restrict. How do, from this perspective that you presented on the paper, can you actually look at new practices, including live coding in gamelan, in using AI, interacting with textiles, and how you see these restrictions to expand to these new ways of including live coding and all of this? I don't know if you have any comments.
Thanks. Well, I think that computer musicians tend to begin their works in a different framework from traditional musicians. I think people from computer music, they generally see a challenge and they try to solve it. it can be a more artistic challenge or a more technical one, but I think this is a really kind of trend in this area. Let's put it like this. And for live coding, I think it's exactly the same. I mean, you can just go and open your favorite language and keep going improvising. But I think with time, people tend to think in a challenge to solve, especially in live coding. So, for instance, there was this Magno Kaliman example. I think yours there are clearly two challenges: one working with textiles and the other one working with the gamelans. And yeah, I think it's a pattern that happens. You have another one?
So the parallels that you drew between SCTweeting and live coding, how do you think they are influenced by abstraction? So SuperCollider tweeting in a quite verbose language. Well, it doesn't have to be verbose, but in the state where SCTweeting started, it was kind of a verbose language. And nowadays, like, live code languages tend to be more and more abstract. So what do you think does the level of the increasing level of abstraction in live coding languages do to your comparison to the parallels that you drew?
Yeah, I think abstraction is a central feature, central point. There are some people tweeting JavaScript code, and it's a really huge area, kind of, and there are super complex codes, and it's sometimes you cannot even translate that kind of code to, for instance, regular processing code or regular SuperCollider, because it's such a, let's say, such an idiomatic way of writing code that it really depends on the abstractions. I mean, I think the ideas sometimes comes from the abstractions. If you also see the SuperCollider tweets by Frederick Olofsson, they are strongly based on the SuperCollider abstractions, on what you can do with the language, and especially this multiple syntax way of working in SuperCollider. And I guess the same is valid for live coding. I'm not a professional live coder. I do sometimes, but yeah, I think we have so many languages with so many abstraction types because people like to facing different challenges and different possibilities with different types of abstractions. So I think it's, thanks.
Okay, if there are no more questions, then let's finish. Let's thank the presenters and okay. Now we have a break, and I was looking actually at but in the catalog there is not the timetable, so I need to change tabs to see what is next. Okay, now we have the lunch, and we need to be here a little bit before 2 o'clock. I think it's, okay, we need to fix this. Okay. 1:45 actually for the official opening, and at 2 we will have the first keynote, our first keynote speaker, Sicchio, over here. So have a nice lunch, everyone.
Yeah? Also a nice garlicky taste in your mouth, or? Thirsty for tonight. Welcome, I'm Fabian van Sluis. I'm the founder of Creative Coding Utrecht. Thank you. And yeah, as with every official opening, I need to thank a lot of people. So I'll start with that. But before I do that, I first give you a little bit of background on how it came to be that ICLC is happening here in Utrecht. So I think like 2.5 years ago, we started this project called On the Fly, which probably everybody knows here. And yeah, so this project really happened during the pandemic. And I think the first meeting was in Jitsi. And we met with the people from Top Lab Barcelona, then affiliated to Hangar. We met with Ljudmila. We met with ZKM and Patrick, Top Lab Karlsruhe, more specifically, Patrick. And we started organizing all these events and meetings online. And we really got along together, actually quite well. And after 1 year of pandemic, we finally could organize, we could visit each other. And yeah, it was really nice to connect the communities, and that basically was the groundwork for trying to organize an ICLC, because we really could connect the communities, and I think this, what's happening here is actually really a result of that work that we've been doing as part of this project. And hopefully we'll continue this in the future. So what did I want to say more? Oh yeah, maybe. Yeah, so maybe I'd like to thank a lot of people, of course. First, the sponsors, the Creative Industry Fund the Creative Industry Fund, the Municipality of Utrecht, Nieuwe Instituut, and all the venues. Without them it wasn't possible to organize this. But of course, more importantly, also all the visitors, all the contributors, all the speakers, you basically made it happen that we are all here. I'm super happy to be hosting you. And I want to, of course, say thanks to the team that makes my life easier because I wasn't completely stressed for the production of this side of things. But I also want to, say thanks to the committees, and maybe every committee could stand up to introduce themselves. The paper committee, we already saw you at work. Could you stand up and Thank you. The performance committee. Yeah, I'm super curious. Yeah, what's going to happen tonight and the rest of the days, evenings. The workshop committee. The community papers committee. A report. And I suppose the Keynote committee, which is me. And last but not least, the reviewers. Okay, well, with that, I want to close off and give the mic to Kate Sicchio, who will, kick off our first keynote talk about the theme of displacement. So take it away.
Great, yeah. Thank you so much for inviting me to be the opening keynote today. I'm very honored because this is my community, and I'm really excited to be speaking to you all in this format. So I'm Kate Sicchio. I'm usually found in Richmond, Virginia these days. I have a position at Virginia Commonwealth University. But before I get into sort of talking about live coding, I think we should start with some live coding.
Hello, I am Kate. Function do, wave high. Welcome to our live coding demo. Let's get started. Please follow these instructions. Function do, stand up. Right curly bracket.
Ooh.
Repeat function do. 3. Step right. Step left.
Woo. Here we go. Let's try that again.
Function do. Raise our right arm. Arm. Repeat function do. 3. Step right.
Like
step left.
We'll get there. We'll get there.
Function do. Raise left arm. Function do. Arms down. Function do. Look right. Function do. Look right. Look left. Repeat function do. 3. Step right. Step left. Repeat function do. 5. Step right. Step left. Function do. Look to neighbor. Function ask. Can it touch your arm? Function respond. Yes, no, maybe. If yes, touch arm equals true. Function touch arm. Touch other person's arm.
Can't find my cursor.
If no, touch arm equals false. Else if maybe, touch arm equals false. Else, touch arm equals false. If touch arm equals true, then say hi. If touch arm equals false, then sit down. Function do. Look at another neighbor. Check if standing. If standing. Ask equals true. Function ask. Can it touch your arm? If yes. Touch arm equals true. Function touch arm. Touch arm. If no. Touch arm equals false. Else if maybe. Touch arm equals false. Else. Touch arm equals false. If touch arm equals true, then say hi. If touch arm equals false, then turn head right. Function do. Look at another neighbor. Check if turn head right. If standing. Ask equals true. Function ask. Can it touch your arm? If yes. Touch arm equals true. Function touch arm. Touch arm. If no. Touch arm equals false. Else if maybe. Touch arm equals false. Else. Touch arm equals false. If touch arm equals true, then sit down. If touch arm equals false, then sit down. Thank you.
So thank you all for dancing with me. So today I hope to bring together several strands of thought around live coding to explore displacement. I'm going to talk about live coding choreography and its ties to algorithmic choreography. I will talk about agency in live coding and how live coding centers around artists. And I will talk about how live coding allows for new possibilities if we allow for both humans and machines to be layered in ways that privilege the poetic and meaning-making rather than technology. And I hope to show that live coding is dynamic, constantly allowing for both displacement and placement to emerge in composition, regardless of disciplinary boundaries. So I'm a choreographer. I started live coding around 2011. I was finishing up PhD research that focused on computer vision systems to make interactive projections in live dance performance. Right around the time I was finishing, the Microsoft Kinect was released. To make the early version of this camera work with your laptop, you had to hack the Kinect. There's whole websites dedicated to hacking the Kinect. But what became interesting to me was actually the idea of hacking. What else could I hack beyond just the code to make my camera run? Could I hack a dance? Or could I change choreography while it was running? This hacking to change choreography live became my first live-coded dance piece. So dance and choreography is not often what people think about when they think about live coding. I've even heard people go as far to say that live coding is a genre of electronic music. but is so much more than sound, and this narrow definition displaces entire disciplines of work that look to on-the-fly composition and computational notation systems. So today I will be talking mostly through the lens of choreography to centralize this as a practice within this community. And I also want to note how excited I am that there's a choreographic coding concert at ICLC this year. Probably that's a very big first. I'm very excited. Choreography is similar to computer code because it is full of algorithms. It is full of rules, instructions, and systems. This comparison is not new, and neither is making dances with computers, which started in the 1960s with choreographer Janine Beeman, who choreographed her piece Random Dance with the help of an IBM 7070 computer to help order the movement instructions from 3 different lists. The computer was made in 1958 and ran on transistors instead of vacuums and weighed 10.5 tons and was stored in big cabinets. That's the beginning of algorithmic choreography. Within this idea of algorithmic choreography, there's a wide range of approaches from a wide range of choreographers. Just to show an example of coding as choreography, this is an example of a single ballet step written out as if it was code by an early top lapper, Adrian Ward. This was part of a project by Scott Dillahunta in the early 2000s called Software for Dancers that looked to find these synergies between choreographers and technologists. And just so you get an idea of what this is coding a glissade, which is simply so all of that code just for that. You can see they say that they didn't get to arm or hand support, and there's another part where they talk about how they want to do an ensemble next, but they didn't get there either. Another example of a contemporary choreographer who's very interested in algorithms is William Forsythe. He's developed many methods for generating movement and then assembling this movement. This is an algorithm from 1998 from his piece Idios Telos that he did with Ballet Frankfurt. And he said when he was designing this algorithm, he was searching for a counterpoint algorithm. And another choreographer who's been working with computer-generated systems since the 70s in Brazil is Ana Liva Cordeiro. So she created this computer system that organized both the movement of the body, multiple bodies in space, and then camera shots for video, because the final product was a screen dance piece. So the computer sequenced the choreographic score through a series of notation of stick figures that indicated the position of the body. The computer then generated this score, and it was given to the dancers. And the dancers had to sort of figure out from what pose to the next and how they would get there. And this was part of the piece, right? The dancer is free to describe the trajectory connecting the positions, and she means describe with movement with their body, right? And while Ana Liva's work is not live coded, it embraces an important part of live coding, agency. There is a performer with freedom to create what the computer has offered. So live coding requires this agency. Bandura in 2001 identified 4 aspects of agency that refer back to the self when enacting, including intentionality, forethought, self-reactiveness, and self-reflectiveness. These 4 concepts start to provide a framework for discussing the amount of freedom to act in a given system, such as live coding. Agency requires an intentional action. That might be intentionally lying on the floor or intentionally typing a variable. This is different from an accidental action, such as tripping and falling onto the floor, or brushing your sleeve against the keyboard and typing. There is a behavior that is deliberate when one has agency. Agency requires motivation. There has to be a forethought that guides the actions of oneself, but also carries the action through to fruition. Agency requires a self-reactiveness that is executable within the environment. Agency thus not only involves very deliberate ability to make choices and action plans, but the ability to give shape to appropriate courses of action and to motivate and regulate their execution. If one does not reflect and see their action has outcomes, they will not be motivated to perform. This self-reflection allows for intentionality of actions to continue. Agency requires deliberate, motivated, executable action. So why is agency important? Nick Collins previously described the placement of programmers and their actions as central to live coding works. When we lose or displace the live coder, what is left? Maybe some interesting software, but more likely uninteresting software. The aim of live coding for me has never been about a computer-generated output, but a computer-mediated process that highlights decision-making. Perhaps the most enlightening live coding dance piece I've created was Vibe Shirt, which was performed at the first ICLC in Leeds in the UK. In this duet with Tara Baker, I live coded a haptic shirt that I could send signals to the right arm or the left arm, buzzing in different patterns at different speeds. Tara then interpreted this sensation into movement. Tara is a very seasoned improviser, has a keen interest in somatic practices as they relate to contemporary choreography. What became exciting in this piece was Tara's response to the wearable. Not when she mimicked the vibrations or the patterns or moved right or left when those motors were triggered, but when she ignored what I sent. Tara would find an interesting movement based on what I had sent her, and then stayed and explored that signal rather than moving on to the next instruction. This meant I had to pause, reconsider, and find a new idea to live code and send. Immediately, I was responding to a person jamming in a duet with my code and her actions. It was not about typing and getting an exact movement. It was about two artists making decisions in a communication that was facilitated by electronics. Here's a little clip of that. Me in the background, in the back corner in the dark, typing away. There's this current zeitgeisty fear that technology can displace humans through automation, but people have always been scared of automation. And in general, automation, the fear is the shift of compensation from workers to business owners, so they'll enjoy higher profits while there's less need for labor. And we see this a lot in terms of the discourse around AI. I have a recent work that used AI, but I used it in a maybe slightly different way. I used AI to purposely displace a person's identity in the idea of providing them privacy. So rather than use the image of a dancer that was not in the performance, I used a style transfer trained on an aesthetic that was made of inky or watercolor-like images. Part of this work was to question the use of AI to identify people and then use AI to blur people. And this was a project funded by a cybersecurity grant, so they were very interested in this. I then used the resulting videos as part of a live coded score for a dancer. The live dancer had no idea who she was dancing with, just that there was humans behind this movement. And then these videos were then live coded in a JSOlang that I created for the Estuary platform called Studio Stage. should say, the dancer in that video is Sarah Dillinger. But another way of looking at this idea of like displacement through technology is maybe live coding allows us to displace technology with humans. And this is much more interesting, I think. So this is an oldie but a goodie video. And I'm always actually surprised how many people haven't seen this. But this is a bubble sort algorithm performed by Hungarian folk dancers. They performed several of these sorting videos and different algorithms. You can find them all on YouTube. In this case, it's not live coded, but it's clearly an example of algorithmic choreography and also computation without computers. It demonstrates something that is part of putting humans at the center of live coding, that humans are interpreters. So we'll just watch a little bit of the bubble sort. Yeah, they made it. It's my favorite part. We can think of dancers as translators of algorithm and rules, but dancers with agency, as well as within improvisational settings, can also be seen as interpreters. Trips Code is a piece I made in 2019, specifically designed to be a live coding language for algorithmic choreography. And it utilizes images in a way of forming discrete units for creating patterns over time. These patterns in turn become composed through algorithmic processes and projected onto the performance space to be interpreted by a dancer. The language itself is meant for a choreographer to utilize while creating the work, and the language uses choreographic terminology as its starting point. But the dancer as interpreter is a key part of this work. The computer is a facilitator in the end, and it's up to the dancer what movement to do, how to respond, or if they just walk off stage and ignore the score. So here's just a little bit of what that looks like. The dancer in that video is Tamara Denson, and a bunch of people have worked on the Trips Code project over the year, including Taylor Collymore and Sarah Graf Humming-Palermo. I'm really also interested in the human interpreter of instructions from Fluxus. So this idea that humans interpret instructions as art is not new, again. The Fluxus Collective in the 1960s and 70s in New York took this approach. If anyone does find this t-shirt, please send me one. Perhaps my favorite Fluxus score is by Alison Knowles. It's from 1965. I talk about this score a lot, and I perform it a lot, and I make all my students perform it as well. If I had more time, I'd make you do it. The way this is written, to me, is very comparable to programming. The first section, there's this defining of objects. Everything, something, nothing. And then there's this list of instructions to execute with the designated objects. So yeah, first you split everything up and you label it, and then you're like, 1, something with everything, okay, done. Then something with nothing, okay, done. Often with my students, I ask them first to perform the score as it is, and then I ask them to live code the score, meaning change it as they perform it. The results are new every time. They make new categories, they like tear up the labels, so we have thing and no and every. They'll grab new objects and add new objects, or they'll simply reverse the order of the instructions. Another artist who works in the live coding realm with no technology is Suzanne Pulser. She's created a performance series called On Off. I'm going to read what she wrote about it. On Off is a series of performance pieces which explore the intersection of performance and digital technology by deconstructing and reinterpretation. At the center of On Off is the body, performing the digital with physical means. On Off radically reduces performance and digital to the act of going on and off and binary machine codes of 1 and 0. A performer steps on and off a platform saying on, off, embodying computational processes in physical performance by writing, executing script simultaneously. The performer is both actor, live coder, and embodied running software. All live coded performances are improvised, but drawing on a pool of samples, so mental images or emotional images that are accessed semi-randomly to create a dramaturgy for the live performance. And it looks a little like this. So if live coding and algorithmic choreography can be done without machines, why should we use computers at all? Merce Cunningham was an American choreographer who famously used the software Lifeforms during the 90s and early 2000s to choreograph. When asked why he was interested in using computers to create dances, he said, software is not revolutionizing dance, but expanding it. Because you see movement in a way that was always there, but wasn't visible to the naked eye. Computers help us see new possibilities. Through machines, software, and algorithms, we are able to displace something in ourselves and see more. So perhaps the computer is not meant for displacing labor, but finding new viewpoints. If we move to new places through our live coding practices, what else can we discover? The layering of tech with agency opens new possibilities, whether that be compositionally, technically, or beyond. In addition to live coding dance, I do live code sound. I have a collective, Cody. I worked with a visualist, Sarah Groff Henning Palermo. We aim to create complex rhythms between the visual and audio components of our sets. We do this by relying on live coding, but also our audience. We feel using technology such as sound analysis to link the visual to moments in the music is restrictive. We want for sounds and shapes and colors to coexist, layer in new ways, and find new compositional moments for the audience to create their own AV polyrhythms. My most recent choreographic work falls into the world of choreorobotics. Amelia and the Machine is a duet for a human and a robot. This piece explores autonomous mobile systems and choreography, but also looks to dance as a way for robotics to learn about expressive movement in human teams. It's a collaboration with Dr. Patrick Martin at the VCU Hive Lab. Dancers are expert movers, so of course robotics should be learning from dancers. And actually engaging in and learning from dance, not dance washing, which is like Boston robotics. We call that dance washing. Dance is not meant to be decorative or an afterthought, but part of a rigorous process. This piece resulted in not only a performance that demonstrated how creative human-robot teams could function, but resulted in a new machine learning algorithm. This symbiotic relationship between dance and engineering is key to this project's success. So the beginning of this piece starts with Amelia, the dancer, Amelia Virtue, teaching the robot a new movement. So in this case, the robot arm has, it's embedded with sensors, so the robot can measure the angle she's moving it to. And this is an improvised moment in the piece. And then the robot has that gesture, and then we can drop it back in later in the piece. So it's not like a traditional live coding as we know it, but there is this idea of live coding behind it, right? There's this moment where the machine is doing something where the input is improvised. To build on this, we're currently working on a new piece called Together Apart, which employs a more recognizable live coding system. Here, there's a robot and 2 dancers that are tracked in space with a low-cost sensor system. The dancers and the robots are then live coded with a prototype of a high-level programming language. So it's all Python-based at the moment. And it gives instructions on whether you should be repelled or attracted. The performers should be repelled or attracted from each other. So the dancers receive this information through a haptic wearable. So if it's like on their right arm, they're repelling. If it's on their left arm, they're attracted. And then the robot just receives the information. So yeah, what we're really looking at in this piece is like these different spatial relationships and how they can emerge through live coding them. And yeah, once one person's repelled from everyone, but the other are attracted to it, then you kind of start to get a line. If they're all repelled from each other, they all end up going into the corners of the room. We also put a sensor on the audience member, so and they did not necessarily get messages to be repelled or attracted, but they could be like, the robot could be attracted to them and then start following them around the space, and they didn't know what to do with that. We're kind of just trying out these different spatial relationships to see sort of how they read in the space. And we're going to keep continuing to develop this piece and hopefully do a bigger version in the fall. Also part of this work is we're looking back to Foresight. And this project he did in the 90s called Improvisation Technologies, which a lot of you probably know of. It was a CD-ROM. Like, yeah. Just get it, like someone's luckily put all the videos on YouTube, so you can access it. But we spent 3 days working with William Forsythe's choreographic assistant, Noah Gebler, who's one of the original dancers on the CD-ROM as well, to learn sort of these different improv systems that he had developed for that project, with the idea that we can then potentially take those algorithms and then apply them to generating robot movement. So going the opposite way in this idea of starting with the dance and seeing what algorithms are already there and then applying them to the technology. And then sort of my last robot piece is my collaboration with Alex McLean, which hopefully you'll all come and see tonight. So we've been exploring movement, drawing, and live coding using Strudel as a way to choreograph robots. And again, there's this layering of human input, live coding, improvisation, and machine motion to create an overall performance composition. Recently, I've also been on a collaborative project funded by the Canadian New Frontiers in Research Fund. And this is a project with Dr. David Ogborn of McMaster in Hamilton, Canada. We've been creating something called Locomotion, which is a live coding language for the movement of 3D avatars on the web. This project has a huge team of research assistants, including Shadan Ahmed, Ashmeet Deval, Melissa Hennick, Vic Wiskowski, Misha Zhao, Esther Kim, Snitty Goldstein, and Andrew Paris. What happens in this is there's sort of these layers of choreography as I see it. We are using motion capture. So there's a human being captured by a machine. This motion capture is then live codable with our language. And then it's reproduced by these digital figures on a screen. So the project brings together screen dance, live coding, and avataring. Here's a little clip. This particular clip was done by it does this every time. See if I can go back. Okay. It like skips this one video. It's very annoying. Let's see if I can get it to go. Here it is. All right, so this particular clip was done by Misha Zhao and Esther Kim. Now we'll go to the loud one. Here we go. All right. So Locomotion can work as a standalone language or within Estuary. So you can do networked performance. This approach to collaborative choreography with motion capture in 3D models is quite unique. In our last performance, I also had this sort of dual role of I was controlling a 3D camera in the space, which to me was this great, I felt like I was making a screen dance piece, because I always think about the camera as another dancer in screen dance. So I had that sort of effect going on. But I also had this role where I was instructing the other performers how to move their avatar in the virtual space. So I was like meta live coding. And I was also doing this translocally as I was in Richmond, Virginia, and the other performers were in Hamilton, Canada. This video clip isn't from that performance, but it's just a really short clip to give you a sense of like multiple avatars moving in the space. This is actually a very old demo now. We really need to update, but. So to briefly summarize my time with you today, there are always new ways of placing ourselves in relation to our code. Live coding allows us to shift, change, repeat, all while emerging compositions are displacing those that have come before. It's important that we embrace the slippage between placement and displacement, allow for human agency, and see the possibilities of improvised performance with programming, whether it be algorithmic choreography, animated visuals, or techno music. Thank you for choosing algorithms, and I hope your ICLC is full of human live coding experiences. I think there's a little bit of time for questions. If anyone has any burning questions. I don't know where the other mic went. Oh, there it is.
Are there any questions?
So thank you. That was a lot of fun, I think, and inspiring. I mean, have you found like that programming can also learn something from dancers in the way that, I mean, indeed, this idea of agency, of course, is very interesting, but also on a core kind of also almost technological level, like how bodies move and interact. Do you maybe have, I mean, you've shown some things, but...
Yeah, absolutely. I mean, that was kind of the starting point of the robot work, was that as dancers, we have so much information about movement, and that roboticists need us. Yeah, so this idea that like, just even simple things of like, like different dynamics, like this idea of like, you don't always want to move at one speed, like that gets really boring. That's boring repetition, right? Like what happens if you like, start to develop that as a motif, right? What if you do it in a different direction, right? Like there's all these ways we think as choreographers that that lend themselves to that kind of work. I think also the direction we're going with the foresight work is really interesting in that we've like deconstructed these sort of improvisational strategies, and then we're trying to teach the computer to do them. So we're like directly taking the algorithms from dance and putting them into a coding system.
Another question over here.
Hi, Gabe.
Hey.
I have a question. So, yeah, clearly. I'm interested in like sonifying different genres of dance, like for example, like Chicago footwork, like dances that have classical, like just like move sets, I guess, are like associated with them. I want to know like if there's been what are the challenges with being able to capture those move sets and then being able to sonify dance and collaborate with different kinds of dancers and things like that.
Yeah, I think, when dance forms have these set move sets, I think the hardest thing to then capture is someone's style or essence or what makes it special when they do it. And I think when we start to capture things, we can lose that, because that's almost impossible to capture, right? That oh man, look at that person doing that one step, it's magic. So that's the hardest thing to capture in that kind of dance for sure. I mean, I think the tempo thing that Lizzie and Alex have been working on is quite interesting. This idea of if something happens repeatedly, then maybe we can pull off of that. And then of course the dancer, I'm sure, will change. But maybe that's a good thing, because then we can measure that change and we can follow that. So that's an interesting approach, is to follow the dancer rather than being when you move this arm, it's going to map to this sound, right? Because that gets really I really hate one-to-one mappings and anything. I'm really much more interested in the balance between doing something and different things happening. Yeah.
Okay, got one question from the online audience. Lee asks if the team has published any of the robotic controls.
Yeah, all of our robotics work is open source. You can find it at the Hive Lab GitHub. And then we've also, we've published some papers on it too, for the, if they look at the Movement Computing Conference, that's where we tend to publish.
Okay, thanks. I think we'll wrap it up here. And of course, we're looking forward to the performance tonight.
Yeah, thank you.
So, thank you.
Okay, is everybody inside? Are we still waiting for people? It seems like most people are here. So, welcome to the third and last paper session of the day. This one will be a bit longer. We'll have 4 presentations, and they will pick up some threads from this morning and slowly fade over to things we'll have tomorrow. We'll start with a top-level view on live-coded music, and then I forgot the order, and I will do it on the fly, as it's habit in the live coding scene. So there's a slight change of format because the first presenters prefer to do a shorter session and answer questions right away. So we'll hear one short presentation and we can ask questions right away. We continue with algorithmic composition and numbered notation, interfaces with machine learning, interfaces with other technology, and live coding will be a topic tomorrow as well. And we will finish the day with addressing accessibility for blind and visually impaired live coders. Don't run away right after the question and discussion session, because we'll have an announcement from the NIME conference, a brief announcement by Diane Verdonk. So with that, I'm giving the microphone to Georgios Diapoulos and Martin Calais.
So, hello. I am Georgios Diapoulos and Martin Carlet. I am a doctoral student at Chalmers University of Technology and University of Gothenburg in Gothenburg, Sweden. And Martin is postdoctoral researcher in Ionian University, Corfu, Greece, and the Hub of Artistic Laboratories. We will be presenting a reproducible musical analysis of live coding performances using information retrieval, a case study on the Algorave 10th anniversary. So, the Algorave 10th anniversary was a big event celebrated with many live streams and physical performances. I wasn't sure if I have attended a physical Algorave, but due to collective memory, I thank Patrick. Finally, I learned that I have attended one in Karlsruhe in 2013. Yeah, so the first study is by Collins and McLean in 2014. So at that point, the notion was quite early. There were 18 Algoraves up to then for this period, 2012 to 2014. As I said, the 10th Algorave had a 24-hour stream that was on in 2 days. And it was just a live stream with 144 slots and 133 performances in total. Or this is what has been the repository in the Internet Archive. So there were 13 physical and virtual events in total internationally. Today, up to December 2022, there were 322 Algoraves worldwide. So in the 10th birthday party, which was the live stream, 24 hours, there were 63 performances in Europe, 27 in North America, 20 in South America, 20 in Asia, 2 in Oceania, 1 in Africa. The good thing is that all 5 continents were represented. It's somehow Western, sorry? 6 continents? Yeah, well, yeah, yeah, maybe. Yeah. Now the programming language is used. There was tidal cycles with 52 annotations. So these were retrieved by the Internet Archive. So below there was a description, and then there was some manual work. That's why they are annotations. 18 SuperCollider, 14 Sonic Pi, 8 Foxtrot, 7 Orca, and one C-Sound, Chuck, Max MSP, and other maybe pure data or yeah, I don't know, you name it. Not an answer, I couldn't figure out what is this about. Very individualistic setups. Now, the study that we present is a reproducible musical analysis based on music information retrieval. So, music information retrieval is an interdisciplinary field spanning from musicology, informatics to psychology and machine learning, DSP, digital signal processing. The applications, they are recommender systems like in Spotify, you get the next recommendation. Source separation we use in VSTs to separate the drums from trumpets. Authority recognition recognize if this is a forest or a city, for example. Now we follow a cognitive MIR approach, meaning that, and the focus is on the musical form, musical structure. So from music cognition, we theoretically separate between primary and secondary parameters. So the primary parameters, they exhibit proportional relationships between them. So the pitch, for example, we can hear if a note is higher than the other, and we can make a mental sort of understanding of this. Rhythm and harmony. So these are the three primary parameters. The secondary may be seen as byproducts. So for example, brightness, it's a byproduct of pitch. I mean, it's higher pitches like 2 to 4 kilohertz. And then pulse, beat, meter, many other characteristics. Now, in this study, we analyzed 133 performances, and we constructed a visual representation of musical form based on acoustical features. So this is informed by music cognition. Specifically, we focus on the shorter memory, which is a time window between 0.5 seconds to 8 seconds. And then based on this assumption that we took, we kind of confirmed some Gestalt principles like good continuation and proximity. So the visual form looks like this. We'll later do a demo and we will explain more. So, but the shorter memory is shown here with each slice. So each slice is up to 8 seconds, and this is like a representation of a 10 minutes performance. Now we go to Martin and to the reproducible part of this study.
Yes, reproducibility to us was a very important feature of the study for two reasons. To get the data from the Internet Archive, there is some conversion necessary to kind of extract the audio from the videos that are there, and then do processing on, pre-processing on the audio, do the analysis. So this is all work that runs for hours for a very long time, and there's software involved to do that. So we want you to trust us. So the results that we are presenting should be reproducible by you to verify it. So that's the classical use of or need for reproducible research. But we also want it to have accessible, this kind of pre-processing we have done, the algorithms are used, you should be able to use them right away without doing all this analysis that you would probably not do. So these are the two motivating factors for having it reproducible. Then reproducibility is actually related to literate programming in the sense that to reproduce something, you need to kind of understand what were the steps, and it's nice to have instructions around it, better the code being inside of the instructions rather than just comments to the code. So Emacs and org mode, I was very pleased to see in the second presentation of today, I think somebody was using org mode, and especially org Babel that kind of was used to run the SuperCollider code. So this is useful for doing live coding as well, so I'm more into that. But in this case, we are running a Jupyter, or we set up a Jupyter environment where you can do coding, even live coding if you like, on the code that we bring along, and we do this through a Docker container infrastructure. You might be very familiar with it. If you're not, just a few words on that. So it's a way to have a self-contained shipment of all the code necessary to run. And in our case, as I mentioned before, we already have made a Docker image that also contains the data. So you can start off that thing and run it right away. We will demonstrate that next. So the build is done by a Docker file. Then you have a container runtime and Docker Hub. Docker Hub is where the image is. So this all together makes this quite popular infrastructure of container handling and building shipment, which we employed here. So you should need nothing else but go to Docker Hub and download the image, and you can run it, and all the code will be there. So, and finally, what was there? Ah, yeah. Okay, that has been, we can step further to the next slide. So this has been realized by multi-stage builds, for those who are a little bit more familiar with it. The analysis is run while building the Docker file, so you can do that. You can build the image yourself, and that means that all the analytical steps will run during the build, and it will take 16 hours or so.
The multi-stage build goes to the Docker build. Yeah. So this is the overall. Yeah, that's the structure how it's done. Yeah. So we use Docker, and so we have a Docker hub, which looks like this. Essentially, what you do is that you can go there, take this line, copy paste it, and if you have Docker installed, you go here and you get the pre-built image. So now I copy paste this to my
the last line.
Yeah, the last line. It's the very last line. It's just a localhost connection to a port, and I open it in my browser, and this is a full development environment here. So here I can open a Jupyter notebook for those who are familiar with Jupyter notebooks, a console, a terminal. I can open files, read files, etc. Now we have one working directory, and here we have some prepared data sets. So these are the acoustical features we extracted with Librosa. And these are some configuration files, and for the annotations and for the, just configurations files, very small. This Docker Hub doesn't have any video data, so we took the data from the Internet Archive, and we mirrored this repository to a GitHub to be more reproducible, because you have the commit there. And from the Git for large files, we take the video data to the Docker, and then we we transform the video to MP3s also, and we'll do the analysis to the audio. And then we run the runtime, which is this. So we have the data, an empty image folder, and the notebooks. The notebooks, it's one notebook officially, and which is this. This is runnable. Now I load some libraries. I make some custom functions. This is an encoding of the acoustical features. Some of the features are it's not a vector, it's a multidimensional vector, I mean. I load the prepared data to descriptive variables here. So for example, these are the MFCCs, the Centroid, etc. And then several sanity checks in the between, unique identifiers of its performance, time tags, namely. And then this kind of a very bad kind of descriptor, like one number for each performance, for a 10 minutes performance, just the mean value of one feature, but nevertheless. And we make some plots out of this, Okay. And yeah. And then we can go to the videos. We can play a video. So, for example, yeah, just the first maybe, doesn't matter. This is how the original data looked like. Yeah, you get the idea. These are the annotations to extract the language. So we made a plot based on the language, which means we make this plot, which means that the language, they do not define how it sounds. So you, regardless of the language you use, you can make all sounds, which is a good thing.
So there are more figures in the notebook than in the publication.
Yeah.
That's interesting to go there if you're really interested and see what analytical steps there have been done. There's more than actually fitted in the paper.
And all this ends up to this visualization, which is a representation of musical form. So we have here, this is a 3D representation. So the radius corresponds to an indirect measure of the event density, and the heat map corresponds to brightness. So the longer, the more events, the brighter the color, the brighter the sound. So here, for example, in 40% there are some cymbals sounds, and here some more like event. And here we see this a blank slate live coding, so we see nothing in the beginning, no sound. This is how here we stop as suppose.
I think you should show the full comparison of all.
Yeah, and
to see the purpose of it. So
yeah. And yes, we can also run. And this will take 45 seconds. In between, I can open this, and I can open another. So you go here, you open another terminal, and I can plot, not that, I can plot the tempo distribution across the performances. And it's here. And now we have also the 121 performances, which looks like this. So you have a comparison. Its performance is normalized based on its own. So we don't do any cross comparison between performances. Its performance sees its own kind of evolution, and the vision there is to use this also for interactive experimentation. So you can kind of have a visualization of your progress, how the performance starts, for example, from 0%, and then here you can see some brightness, and then less bright, etc. So, yeah. Do we have time for questions? Or yeah. Yeah.
There we go. So my question is, as I understand, these are plotting throughout the relative duration of each performance. One piece of information that is not, I guess, not so easy to extract from videos, but could be possible, is how regularly new code is evaluated, or how long between different evaluations of code. So then it could be interesting to also plot the difference in sound between evaluations, and to see how how different performers treat evaluation as more or less drastic changes to the sound.
Yes.
Are there any other similar things that you thought about but didn't have the time or the resources to
Yes, so this corresponds to the video data. If from the video you can really identify when, because some systems, they do have this code highlighting. This analysis is only based on the audio, so we don't use any video. So you can do that, do some computer vision analysis, and then some systems, they don't have this. It's quite hard to know when something is evaluated. But yeah, I mean, for Tidal or Strudel or SuperCollider, I mean, you can definitely do that. That would be very interesting.
I guess it would also be really interesting if you had access to the OSC data or the actual patterns that the code generates.
Yeah,
as
I
well,
think that's impossible. How you can?
It's impossible for concerts that have happened without that being taken into account.
Yeah.
But maybe moving forward, if live coding instruments could have an option to actually keep a record of all that, that could also be interesting.
Exactly. You should forward the question to there's a session on how to document algorithms.
Oh, right. Yeah. That could be.
Document exactly
yeah. So yeah.
How frequent code was.
Yeah. Anyone here who makes live coding instruments?
When exactly?
Yeah.
So all the text, if we would have it.
Yeah. Exactly.
We would use it immediately.
Yeah. Thank you.
Any other questions? Anya.
Yes, thank you. So, of course, here you can see the form of each individual performance. Were you also able to maybe like see if there is some trends coming up, like for example in the form that, because you know one might think that, or sometimes critique on live coding might be this that there is always a very slow build-up. So is it true? Were you able to show that with your data?
Yeah, I mean, if I understand, so for example, here we see a climax in sound events. The good thing here is that you can easily spot some perceptual. You can easily, see something and kind of hear how it sounds. So if we go actually on this video and we go on 40%, we're gonna hear this. So you have fast recognition of climaxes in the music, etc. Was that your question?
Yeah, kind of.
Yeah.
Because
confirm this image would confirm your prejudice that you just had.
Yeah, right. This would confirm the prejudice. Yes.
Yes. If you look at the whole, you would immediately see that it's not true. Fully.
Yeah.
So
yeah. I mean,
if you change to the image with where you can see all of them.
Actually, yeah.
It's very surprising that you see very different forms, right?
Actually, yeah. What this shows, and this is only for one feature, is not a 3D. This is just a 2D. But if you do it 3D, etc., I mean, what it shows is that everything is totally different. So the diversity is enormous. Nobody plays as anybody else because it's an improvisational practice, and that's.
Thank you.
Yeah.
With these specific ones with much yellow and the big ones, does that mean that there's less dynamic than in the other ones because there are less quiet parts, or?
So these specific, they show only brightness. So.
Okay, but the length is, what's the length?
Yeah, so the color here goes with the length also.
I thought the length would also be the
no, this is a 2D. This is a 3D representation. So here, what's your question exactly? If
just
so here the length is.
Try to analyze the dynamic of the loudness.
Of the loudness, for example.
Or the difference in dynamics in different performances. That was my question. Yeah.
Yeah, I mean, for example, if you map the length here to this feature that you talk, and the other to whatever, some pitch. So the length here is a rhythm-based feature, and the color map is a pitch-based feature. So you can use this to and just plot whatever you want, like the dynamics you say, and then the I don't know, the spectral centroid or some other, like how flat is the spectrum, maybe spectral flatness, and you can get that. Yeah.
Maybe the typical answer here would be go into the Docker, open it, change a little bit of code, and you plot it differently, and you answer your question. And that's actually a value of that study, so that a lot of infrastructure is already there, and you could put your questions or you could formulate your questions rather easily by changing and following the code that is already there, changing a few mapping parameters, and you get a different plot that kind of gets you to that point, and easily to an overview of all of them. So that's interesting way of interrogating the data. Yeah.
I think we are over time. Right? Yeah, thank you.
Next we have Mika. He'll present something that was already hinted at this morning. Ciphers, or ciphers, not sure how sharp he wanted that in there. Algorithmic or number notation for algorithmic composition. And let's give the stage to Mika.
Okay, yeah. It's good. Okay, hi everyone. My name is Mika Alonen, and I come from Finland, Helsinki area. I'm a part-time doctoral student at Aalto University in the Department of Computer Science. My main research field is linked data and information management, so this is more of a distraction from my main research field. But still I'm really serious about live coding and learning a lot about music meanwhile. So my background is more of a software architect, and I work as a software architecture consultant and doing the part-time doctoral studies. The other author is Raphaël, who has helped a lot and encouraged me to write about this subject, and he also pointed out that there's some novel concepts, and it's good thing to write about this. Okay, what is ciphers? It's a number-based notation for live coding and algorithmic compositions. So it's a iterative result of unifying different kind of notations used in traditional score and historic numbered notations and live coding. It started as a personal project that could run in Sonic Pi buffer, but it has grown over the years. It's now about 5 years old. And basically, first I reinvented the numbered notation, then I started to learn about the history of notations and uses in live coding and different mini languages other than Sonic Pi also, so it has evolved and grown in the different directions. And it has also further developed through a discourse within the Sonic Pi community in the forums, and there's have been a lot of helpful comments and posts about how to improve the notation. Okay, let's try if this works. Still. Oh yeah, it sounds so. So this is the basic notation. Numbered notation here means that these are basically pitch classes in a scale, and by default it's a major scale because I haven't defined anything else. Other than that, I can also use characters to describe some samples, and then I can do different cutoffs and things like that, what Sonic Pi basically offers. Okay. When I first started to live code with Sonic Pi, I got frustrated with the kind of data structures that were used in Sonic Pi to create the pitches and the rhythm. So there were separate structures for creating sequences of pitches and different structures for creating a rhythm. I wanted something that describes the both in an easy way. So I first invented the numbered notation, but then started to learn about the history of numbered notations, and then named a new notation after cipher system that has been developed by Natorp in early 19th century. And basically it looked like this, and I wanted to create a live programming and algorithmic composition language that can be used as simple as this. So you can define different lines of notations and create loops out of that. Then I went really deep into the history of numbered notations. So let's do a quick overview. It's really interesting and complex and contradiction history, where there's always some reference and article that mentions numbered notations in a sideline, but there's no comprehensive history about numbered notations specifically. The first occurrence of numbered notation was in the 16th century. At least it's the only one that has survived. Pierre Davantes published the Psalms of David using numbered notations, and his idea was that it would help singing. Usually the notations is only for the first verse, and then he used numbers for the second verses. You can see behind that you have the melody in one line, then you can have numbers in the following lines, so it would help sight singing. And next one was Antoine Parent, and he used this notation for more advanced contrapuntal notation for creating these polyphonic presentations, and he also devised the first numeric stuff. And then Kirster Athanasius invented Arsamusa Rhythmica in the 17th century. He used combinatoric techniques. Probably these were unique inventions. They might have known about each other, but it's also possible that they didn't know that they were inventing the numbered notation separately. And this was also the kind of first algorithmic composition in a physical form. And then probably the most famous, Rousseau developed his numbered notation in the 18th century, and it was widely ignored, you could say. They praised that it was innovative and good, but it didn't get widespread use. Then Ludwig Natter, in the 18th century, he reformed music pedagogy in schools, and he used numbered notations to teach singing in elementary schools. And after that, Colin Peer extended Rousseau's notation. And even though these are in a timeline, it's probably possible that they didn't know about each other's publications because books were still a bit scarce in these eras. And then the Nordic instrument psalmodicon was very heavily influenced by these numbered notations, and first psalmodicon was developed and invented by Lars Rovrund, who got the idea from German monochord, and he also created his own notation, numeric notations for teaching this one-stringed instrument, and it was used widely in the 19th century in schools and churches. Similarly, psalmodicon was invented in Sweden, and it's also not known if they knew actually about each other, and I also managed to find this Finnish numeric notation book from local bookstore that defines this building instructions for psalmodicons and also way to perform a ceremony. And in the mid-18th century, the Galin-Paris-Chev method was built on top of Rousseau's and Galin's and ideas to, and they were actually building this kind of a school. They were teaching this notation, and they gave certificates to people who learned this notation. You can see the certification on the background. Then Heinrich Franz published a choral book that was used widely across Europe in Mennonite faith and also in Russia. In the beginning of 20th century and bit before, the numbered notation also spread to Asia through Christian missionaries, and in different countries, for example in Indonesia, they created their own numbered notation, for example for gamelan in Indonesia, and also yampu in China. That was improved the local Gongcha notation. And of course, this is basically an unrelated innovation by Schönberg, but in ciphers, these ideas about using numbers and arithmetics are combined. So many ideas come from the 12-tone technique and post-tonal pitch class theory. Okay, so the objectives for the notation was always this minimalism. What is the most minimal notation you can use to compose music and live code? And what is the most minimal in a way that isn't mentally challenging if you compare esonangs like orga and byte beat? Byte beat is much more mentally challenging. How does the orga make the language simple but very effective? So in a similar way, Živa's aim to create most minimal numbered notation for live coding. And also flexibility, so it should be suitable for live coding, generating sheet music, do numerical analysis, and be open for multiple interpretations for the numbers. So pitch classes, degrees, interval sequences, or MIDI or CC message or anything. And also the learnability was a big objective. So it should be really easy to learn and write any musical sequences in any key, and possible to write down ideas quickly in anywhere, for example, notebook or do the live coding on live setting. And also the interoperability. So the idea was that to create a notation that would work in different live coding environments, not only one, and also enable transformation from traditional score to live coding and from live coding to traditional score. So the implementation, as said, the first implementation was in SonicPy Buffer in 2018. Then, after many iterations, I also did MuseScore export plugin in 2021, and new generative parser using Treetop Beck in 21-22, and also just months ago this Scala scale parser that enables you to do microtonal melodies also. And also the first implementation for Python that enables it to be used in Sardine and also in MosAIck 21 algorithmic composition framework. So the architecture for the SonicPy looks like this. It's built on top of SonicPy as an extension using monkey patches and all kind of hacky and ugly things, but it works. You can use any type of, or most type of inputs as a parameter. So you can do string patterns, you can do integer patterns, you can use arrays or lambdas or these enumerables which can generate any kinds of number sequences. And you can create music from pi sequence or any kind of mathematical sequences. So there's few main methods. Jet play method is basically playing the melody once. Then there's loop method and also parse method that both of these methods uses. And those are using those parsers. There's 3 different parsers. The basic parser for basic melody and generative for creating these more complex melodies and for creating different kind of algorithmic patterns. Was that 2 minutes or? Okay, so I already told about the Živa's for MuseScore plugin. You can select part of the melody and it outputs Živa notation, so you can then play it. And you can add, for example, different kind of transformations to the notation that then when the melody goes on, it creates, for example, retrograde or changes octaves and things like that. And then you could start messing with the melody and start to create different kind of algorithmic things or anything. But it didn't work. Let's go really quickly, the basic notation and stuff. So, as you saw, it uses integers to define pitch classes, and then you can use scales. You can use integers, arrays, or enumerables. Pitches are defined. You can use negative pitches or positive pitches. The new version uses the pitch class notation and not the degree-based notation that is used in these historic numeral notations, because in our experiments we noticed that it is much better to use the pitch class notation because the zero provides this kind of a natural inversion point, and also it's not really useful if you create these arithmetics that create zeros that would be rests in the notation, because in the traditional notation the zero meant rest, but in Živa's the zero is the root of the scale. And the note durations you can use these characters. So for each typical note length there's different characters you can use. So this is I think all know this melody. You can also use dotted notes and things like that. It also includes ideas from tidal cycles, so you can use the note lengths, or you can use rhythm subdivision, things like that. So these are the same melodies with different kind of notations. There's a lot of different characters for different durations, and the chords uses the most minimal syntax I could think of. So they basically, chords are grouped as numbers, and it's a trade-off between scale degrees that has more digits than 9, but it's the most simplistic way to define a chord. And you can also use those Roman numerals. And then the generative notation I mentioned had also these minimalistic syntax for creating random numbers and loops and different kind of things. And some of the inspiration also comes from traditional notation. So this is the notation for traditional loop. So it would repeat it 2 times. And then you could also do loops with random numbers and things like that. And then there's much more complex list operations you can do. You can do create lists, which are basically containers for numbers, and you can sum them together to Cartesian sums and create this algorithmic sequences. And it has a lot of other stuff that I don't have time to go through now, but you can also use it within Sonic Pi, so you can use it as a way to play a scale. And let's jump to conclusions. So numbered notation is really well suitable for algorithmic composition and provides easy introduction to this exploratory live coding, and for especially those who are not familiar with music theory. You can just use numbers to explore scales and define your own scales and see what comes up from the random numbers and loops and transformations. And as mentioned, there's also a new version for Sardine, so you can use ciphers with Sardine, and there's also some support for MosAIck 21, so you can also use it for generating scores, for example, with the MosAIck 21 framework. Okay, thank you.
Cool, thanks, Mika. Let's keep questions for the end. And
Do we take questions now?
Well, kind of. Yeah, let's do them now because the topics today are a little bit divergent. So let's do them right away for this session. And yeah, does anybody have a question? So, yes, go ahead.
So have you, so one of the things, just because you're drawing a parallel between Western notation and sort of other more contemporary forms, the thing that I find really powerful about Western notation is that it uses the y-axis as well for really important information. And usually when you're reading chords, for me at least, it's much easier to look at the overall shape and the first note, and then you extrapolate what the other notes would be based on their distance. So it's a relative specification for the chord. So my question is, have you played around with specifying chords by using the first number to specify the absolute note, and then each other is as a relative number for that chord? So let's say if you wanted 5, 2, 5, it would be the fifth note and then 2 notes over that and then 5 notes over that.
I thought about it, but it's not implemented.
Okay.
Something that would also be really good. So basically using intervals.
Yeah, but only for the rest of the chord, not for the first note. And then my second question is, have you played around with using superscripts and subscripts as some kind of way of faking that y-axis of Western notation? So having a number and then a superscript number over that, or a subscript number underneath that.
I'm not sure what you mean by subscript.
So it's when you have 2 to the power of 2, for example. That's different to having 2 next to 2. But would that be would that be useful or interesting? Do you think?
I'm not sure if I understood still the question.
So the question is, instead of just having numbers right next to each other, if you could stack them vertically somehow, but the only way you can do that today in, let's say, a browser environment is with a superscript.
Yeah, of course, but the idea was to use basic ASCII notation and kind of make it a notation so that you can write it down in any text format. And actually, if you use ciphers and this ciphers or J-tracker notation, that if you have stacked multiple lines, it means different things. For example, you can do polyphonic sequences. So if you have multiple lines, they sound at the same time, or you can do also the same vertically, so kind of tracker notation type.
Cool, thank you.
Okay. Any urgent questions? We're kind of short in time and a little bit behind, so maybe we can still. People are still around, so there's still plenty of questions. Now we have from algorithmic composition to interaction with machine learning models. Junichi Shimizu presenting the Jenny system. So let's give the stage to Junichi.
Do you want to mirror your screen or?
No, really. I didn't do that. Seems to recognize me.
Where is your other your preferences? Yes. Should just I don't know.
Some technical problems. Sorry for that.
I have no idea, but the other one works, so. Thank you.
Sound is connected here.
Yes. Okay. Thanks so much. Hi there. My name is Jun Shimizu. I'm a visiting researcher of Creative Computing Institute, and today I'm going to introduce about Jenny, designing and exploring live coding interface for generated models. My co-author is Rebecca Pibernat. She's also a professor of Creative Computing Institute. So what is a Jenny? Jenny is a web-based live coding interface. We built new environment from scratch, and we built some generative model API for interacting with generative models such as VAE and RNNs. And also we provide lightweight code patterns to generate rhythm sequence. And also we discuss some transparency and authorship and creative expression and visualization technique. And another aspect is also we exploring some design pattern with using this interface. First one is the we made some model API to generate the rhythm pattern to get from generated models. And also not only the using generated models, we prepare some pattern functions which mainly for making rhythm patterns with for live coders. And of course, we can combine this technique with a combination of machine-driven generation and also human pattern making process. And yeah, we provide several avenues to making a feedback loop to machine and humans for the live coders. So let me start off the experiment a little bit about background of generative models for live coding. First of all is more broadly generate machine learning algorithm for music creations. So I think you already know about, and they have a long history. First one is using Markov chain model, like more stochastic model to generate the musical sequence. And more recently, RNNs, VAs, or even transfer model can doing a lot of capable things to do. So they can also generate the entire novel musical sequence from scratch, or even generate continuous or partial sequence from provided user's data. And if you look at tools for the interface and general models, machine learning, the MosAIck, they have several works in here. Most famous one might be here, Google Magenta Studio. They are building music production tool available in the VST or web applications, but it basically mainly for the music productions. And some researchers even try to figure out how not only providing GUI tool, but also a combination of developments, the model itself, and how can apply these controllable models with GUI. But most of the work is the releasing as a GUI, and there's no, because they don't want to focus on programming in the environment for the users. But if you look at some more live coding context, they have some similar works in try to apply to general models to the live coding or programming. So there is a MosAIck. This one is a web-based programming environment. They're providing really high-level API wrapping machine learning functionality. And at this moment, they didn't focusing on the live coding stuff, but they can possibly apply this programming environment to live coding interface. Another example is a SEMA. This one might be most relevant work for our research. They're also building some live coding environment, but focusing on users' own live coding, designing users' own live coding language. And these programming environments require really substantial boilerplate code and resource efficiency. So designing live coding language for general models still has a huge challenge, because if you look at general models, they have online, offline inference. We need to care, and the model size is huge, or we have to use pre-trained model or users trained data, and what kind of data, media or symbolic or audio, generate from this model. And the live code environments, of course, we need to inference the mass in real time, and of course, current the live code environments mostly not built for the designed for the machine learning or general models. So how can we design the whole workflow more friendly, accessible for everyone? And what is the gap? So I started to making some API for more accessible the researcher and also live coding context. So this one is our implementation of how general models can apply in the live coding editor. So here is a configuration file, which mainly for used for model developer. So here's a list of which model the researchers or developer are using, and what kind of parameters the models are available, such as this model use this checkpoint, or this model using temperature, or any other properties. We write down this in the configuration file, and also not only the write down the model parameters, but also some describe inference method to get the result from general models. But of course, the other interfaces, live coders don't know what kind of models API available from these interfaces. So it connecting these configuration file to the interfaces, and then live coder can easily access the each property through this looking at this configuration file. So how Jenny works, I will try to explain a little bit about short explanation using the video. Okay, yeah, I will explain more detail in later. But so yeah, Jenny has 3 UI components. First one is code editors, as you can see, and also they have console view to output data, to see the data, and also the pattern sample button to switch between template code. So code editor is basically a place to run the code. It is basically JavaScript based syntax. And of course, we support some auto-completion assist to access the model parameters more easily. And we have some two types of keyboard command, execute command code, and also interrupt stopping audio command. And another component is a console view. This one is notifying the UI status. So when updating the code, the user get from the result from the general models, and this console view basically shows the whole result from general models, so the coders or audience can understanding what can data get from this model. And of course, we have some template code to run at first, so we're preparing some pattern sample button to switch template code. And another specific implementation is that we design pattern representations for making the rhythm, which is not using the generic models, but the people can making the rhythm with using this pattern. Right now, we focus on the rhythm. So as you can see, they have two signatures. One of the signatures is time representation. Another one is mid-note number, which corresponding to the drum type, general MIDI type. And this time signature is specifically from borrowed of Tone.js. Tone.js is a web audio API for making interactive audio. And current limitation is we can only define two measures, and but we're using the Tone.js more easily to execute a command without stopping audio or interrupting metric flow. So here's how to use the pattern object. Yeah, it's quite simple. Just defining the rhythm, the representation, and following that playing function to play the pattern or not. And also, we did a couple of visual expressions. First one is a JS background, so we support some JS script to show some visualizations. And also, we specifically designed for some method, similarity visualization, which is basically calculate the similarities of data from general models, so the people can understand these data were similar before and afters. And these two dots we can see, these correlations show the similarity. So if the dot is small, distance is close, it means similarity is high. So yeah, I can play some basic video. Yeah, I hope you can understand when the generated data sounds different, this similarity dot is gonna be more, far distance. So yeah, how to use these pattern in practice for the live coding. So basically we have fundamental method to generate the data, which called gen functions. So every model is following adding this gen function to get the data from general models. And optionally, we have preparing some output function so when we generate some data, the live coder can generate data through logging from the output function. And why we need to output functions? So I'll play this video. So yeah, it's not only about getting the result from generic models, but also transforming the new patterns to making or modifying your own rhythm. So we're making the output function to get some result and modifying and transforming the new pattern. And also some other methods will be available, but not this one. Not that this functions depends on the general models. But in this example, we have some input method which can feed it into the data to generate make the variation to the from the models. And also interpretations method was combinations of different patterns to interpret the rhythm. And so here's another example of how transforming the rhythm and making new pattern with using input method. Yeah, so the last part is we control the temperature, the property. It means making the more different variations to from the based on the input. So the live coder can explore. We want to make more similar variations, or we want to make more not similar variations. And they have some other types of generic models. I quickly play the video as well. So steps meaning how much do you want to make continuous melody. So if I put in 60 or 32 notes, which means this model can generate the 32 notes based on their input. Okay, so this one is the last video, but I will try to play it again until you got the idea of our work. But yeah. Yes. So this video is just the iterative process to how to make new patterns using getting from the general models and converting or transforming their own data. So I will a little bit discuss about this work. So first one is the transparency. We need to expose more substantial factor of general models and algorithm to make sure what kind of models we are using. So we have some in the configuration file we have some setting for describing like checkpoints, which means it's not mainly does not change in happen in real time, but we can show at first and the checkpoint to show what kind of the models we are using. And output functions and console view help to understand what kind of data from get from general models. And even without output functions, we make sure console view can see the result. And data reliability bias is not addressed right now. We think we need to more add some supplement text, such as what kind of data set we're using, or size or license, something like this. In authorship, we find that these design iterative process to improve their authorship. As you can see in lots of video, we're making a variation from based in the user's own data, and then we can transforming without live coding the human pattern making process, so they can easily modify or combining other own favorite data. And even we can layering the model patterns at the same time. So even we delegate the models too much, but we have some still human pattern making the data. And current the limitation is we focusing on only rhythm patterns, and we did not support training on data set. And another discussion is creative expressions. So yeah, basically, if we don't have any code or beforehand, we can just start in global expressions, which means we can generate really random data from the models. And then if we found some favorite data sets, we can just locally expressions. And we still have need to consider level of abstractions. We currently, very small number of the options we can support to generate, but potentially general models have a lot of capable things, so we can more applying these lots of possibilities to challenge. And other data set like melody or audio might be good for the exploration. And yeah, last one is visualization is even very simple, like showing just only similarities, but might be helpful to understanding. So we want to continue to investigate the other visualization method to the effect for the live coders. So what's next? We want to more explore intuitive data representations, and also we want to publish their components and more applying or combination of current live coding environments. And also we want to more adding some current general models. So here's a summary. So we introduce Jenny, web-based live coding interface designed for working with general models. And we show some how these patterns can unfold several unique design patterns and for live coders, and what kind of interactions can we make. And we discuss reflects on our implementations, transparency, authorship, creative expression, and visualization. Thank you so much.
Thank you so much for your presentation. Yeah, let's continue with the questions. Anybody has a question for Junichi regarding the Jenny system?
As an alternative to the output function, would it be possible to pass a random seed to the gen function to always get the same result?
Sorry, could you say that again?
So if I saw it correctly, each time you evaluate, you get a new generated pattern.
Yes.
And then you use the output function to fix that pattern.
Yes.
But could you also pass a random seed, like some number, to the gen function to always get the same result?
Yeah, right. That's really good questions. It depends on I think the models. Current models does not support like random seed. So yeah, if you have like more huge models, I think it would be great to setting like random seed or setting some even the randomization. Yeah.
Thanks.
Any more questions?
Do you see any hope to like use these kind of models on languages which are only used by one person, like obscure languages which do not maybe have a large body of code yet, but yeah,
just only use one person. So.
Okay,
yeah.
Okay, so there's hope.
yeah.
Yeah.
Maybe one more question, if anybody has one, of course. Yes? Sure.
So I saw this temperature. So when you adjust the temperature, do you think you can kind of guess how it will sound a bit? So if it's increased, the temperature value, it sounds more, I don't know, chaotic, and if it's less, it's like this?
Yes, yes. So the temperature concept is the, how do you want the generate more randomly? So if the temperature's the high, the users or our expectation is get the data from more randomly and more far different the melodies was data. So, but sometimes the general models does not understanding the perceptual similarities or randomly. So it might be so that is why we added some similarity visualizations to understanding difference between the general models and humans perceptions.
Cool. So another applause for Junichi Shimizu and Jenny. Very promising system. Next on we have Matthew Caney, addressing accessibility in blind and visually impaired live coders. And while he is setting up, I want to apologize to Mika because of my own tiredness, the delay in time, and all the technical trouble, I didn't give him proper thanks for his Zephyrus notation. So another applause for Mika. Sorry for that. Didn't get too much sleep last night, so. Okay, let's get this started. Is
just connected, but. We'll see. Oh, yes, I will. It recognizes that there's something connected, but I could try.
Yeah, it's also sometimes a power problem that. None of them? You got it working before.
recognizes that there's something there.
Yeah, but it's a frequency problem, and it's all the time with the Mac because it doesn't work. Sometimes it helps to put your computer on power, especially with or on and off.
You mean plug it into power?
Plug it into power because it's USB-C.
Sorry. Having trouble with the projector. Yes.
Here. Reconnect. Oh, that's annoying.
Yeah. Just Google Slides.
Google Slides?
Yeah.
So it could be done on any laptop?
Yes.
Should we try another laptop?
Yeah, really sorry for this.
Yeah.
Try one more time that other hub.
Try another laptop. Do you want to try mine? If
Okay.
Yes.
Yes.
Does HDMI directly seem to work
Yes.
better?
Yes.
So
And then do I?
Kan je deze even aan? Je moet wel daar blijven. Ja, oké. That one works.
Yeah, or just how difficult is the link?
It's pretty bad.
Okay, then just send me the link to. Do you have Telegram?
Not on here, sorry.
Or then Nick at parkerlipson.de. Okay. Park Ellipsen. P. You like the park? Okay, there's your presentation.
Okay.
Okay. Problem solved. Let's continue with Matthew Kenny addressing accessibility for blind and visually impaired live coders. I'll give the stage to him.
How do I do full screen? Or what's full screen?
Sorry?
Like
Again?
full screen on.
Full screen. F11.
Oh, F11. Yes. Yep. Yep.
Cool.
Yes.
Finally.
Thank you so much for staying around, and I'll be quick. So, oh my goodness. Oh no, what have we done? Okay. Oh no. Yes. Oh, okay. Perfect. I'll get back to Yes. Okay, so yes, this is our presentation on work that we've been doing around accessibility for blind and visually impaired live coders. This project in particular has been with a group of blind and visually impaired students, learners. So we are I am Matthew Kenny. I'm a performer based out of New York. I do music and visuals with a variety of different languages there with LiveCode NYC, and also my interests include development of live coding tools. I've made some open source contributions to Title Cycles itself. I've sort of built various versions of experiments with editors and collaborative systems. And then I worked together with my friend Willie Payne, who has just finished up his PhD at NYU, where he was working with the NYU Ability Project, which is a lab that deals with accessible technologies under the direction of Dr. Amy Hurst. And most importantly, over the last couple of years, he's been working with the Philemon M. D'Agostino Greenberg Music School, which is a community music school in New York, a pretty unique institution in that it's a school for blind and visually impaired musicians. It pulls adults, children, kind of people from the community of all different ages, levels of musical expertise, and that's Willie here on the left getting some pizza with one of the students right before a recital. And he worked with them for 3 years prior to this work, kind of formed a relationship both with the institution and with these students, and kind of helped do transcription of music into Braille, helped lead various classes or teach one-on-one, and he's been doing a kind of research with accessible music interfaces. This was a previous kind of work that sort of precedes this called Sound Cells, where it was a web-based text editor, because text is very easy to make accessible either through screen readers or Braille displays. And essentially the editor, it's pretty simple. It uses ABC notation, a sort of pre-existing music notation that's all ASCII based, and a lot of music already exists in it. And then this editor was designed, as you can kind of see, to be very customizable so that you could have different, you can adapt the colors or the font sizes depending on exactly how much vision you have, and then you could export either PDFs of a print score or a Braille music score. And kind of based on that work, he wanted to get into live coding, because live coding as a text-based tool for music making seems like an obvious, kind of potential tool in the toolkit of, blind and visually impaired musicians. And so we set up Philorc, the Phil Laptop Orchestra. Right now it's a group of 5, all about high school, sort of teenaged music learners who have, a lot of background in music. I don't think any of them had any particular background in programming, certainly not live code specifically. And so with this, we wanted to both figure out a curriculum and an environment for them to learn live coding, in this case with tidal cycles, as well as figure out how to make tools that work well with them and that they can interact with. And, the tools that they use, kind of speaking to the diversity of different vision abilities, are all different. Some use iPads with magnification and very large text. Others use MacBooks and the Apple voiceover software. Various of them use hardware Braille displays, which can refresh and generate the Braille representation of a given line of text. And so incorporating all of that, we set up a learning environment built around a kind of in-development experimental text editor that I've been building, and that I'll get to in a second. But basically, we kind of structured this weekly class around initially sort of small prompts and lessons that would incorporate a couple of, like ideas from Tidal, certain syntactic constructs or certain filters or different effects that you might use when manipulating samples. And, because these are learners without, with low or no vision ability, of course we can't do some of the typical things you do in a classroom. We can't project code for everyone to look at. And so we really worked within the editor, taking advantage of the fact that it was this collaborative document that everyone was in at the same time. And so we would start out with code that would have comments, maybe describing, okay, this is a bit of code, this is how it works, or this is what it does, and maybe offering a prompt to, okay, take this pattern and adjust it in this way, or add a sort of secondary effect on top of it. And, out of that, a sort of process of developing the ensemble and developing the sort of things that they would perform kind of came up. In addition, we had some physical materials that we would give out. And, again, trying to meet everyone's different needs, we sort of designed these handouts so that at the same time they'll have Braille representations of text. They also have printed text, again, very large so that it's pretty readable. Also, some of these, particularly, we've got a graphic here of various different, common waveforms, things like that that are typically expressed visually. We used a variety of technologies that allow you to create tactile graphics. So either they're embossed, or there's a technology called Swellform, where it's an ink that actually expands the paper when it's heated in an oven. And so with that, we kind of took that material, did that process of running these classes, kind of building up people's understanding, and then at the same time, we're working in this kind of in-development text editor that I'd already sort of started and then have been continuing to develop alongside this course. It's called Text Management, which is both the name and URL, and currently it just points to the GitHub. There are a couple of pre-releases, but that is going to be a sort of ongoing project to build a what will hopefully be a more general purpose live coding IDE. It takes advantage of the fact that the recent release of the Code Mirror kind of JavaScript code editor has the best screen reader support so far, which is to say it's still not perfect. We've been going through the process of discovering which particular IDE features don't play nicely with the screen reader or on certain browsers or on certain platforms, and trying to customize and adjust and like figure through problems as they come up. And like I mentioned, it has this collaborative structure. And so here's the architecture that we used in these classes, which will be very similar to Flock if you've ever used that. Basically, there's an online kind of centralized document, and then each learner has their separate browser code editor, and then the instructor was playing the generated audio on a single kind of machine attached to speakers, which was good because kind of synchronizing code as opposed to synchronizing everyone's music simplifies the process of mixing all of these different musical streams together. It also allows individuals to use headphones and listen to the voiceover of their particular code on their particular line that they're editing without it impacting the music in the classroom. And here I can show you an example of a moment as they're sort of all adding things and kind of listening back and forth. And there's a moment right here where it gets more and more chaotic. And there was a sort of a rapport that built up and certain kind of norms around how do you do collaborative coding together that came, both from the fact that all of these learners have been at this school for a while, they know each other, and because of the particular way that they were working, they figured out, okay, it's okay to silence other people if you ask them, or perhaps you can silence everyone, but only kind of in an emergency, and it became this sort of balance of these relationships and how do you kind of add without going overboard. In this case, it turned out that someone had decided to, I think, create a pattern with, a thousandth subdivision of a beat or something, and it was just generating far too many events. Yeah, and so our reflections on this and sort of issues that we're still working through is that, of course, coding is challenging to teach under any circumstances, and we've had to figure out how to address confusion around syntax, confusion around just all of the particulars of errors that'll crop up and such, in addition to the fact that there are many screen reader issues still. Browsers are not always consistent in how they, kind of represent what's going on the screen. And also there's a full universe of other collaborators or, IDE pieces of feedback that you would expect, syntax highlighting, that sort of thing, if you're looking at a visual presentation of an IDE, but within the sort of one-dimensional stream of, audio description, there are a lot of challenges to sort of design around. But on the other hand, there's a lot of potential here, both for this population of musicians, but also for the live coding community broadly. Like I mentioned, text-based creative tools are particularly well suited to people who don't have much or any kind of vision ability. And by building these tools, or building these features increasingly into the tools that we use, that kind of fulfills this desire of the live coding community to be a very open and inviting and kind of accessible in sort of every sense community. And this can then, this brings new people, new musicians, new developers, new feature requests, and new ways of performing, because in the same way that we want to make performing accessible to blind performers, we also want to figure out, okay, then how do you represent what's going on to a blind audience member who can hear but wouldn't necessarily be able to see projected code? Are there other ways that you can be incorporating the material of live coding? And then as you're sort of adding more complex, or sort of more layers to the presentation, these layers become things that can, feed into the, the sort of artistic work itself. And I'll mention, kind of going forward, this group had their sort of first premiere concert was last December. This is them rehearsing for that. It was part of, a larger kind of end of semester recital for the school. And going forward from there, we did a follow-up interview study talking to the students and then figuring out, okay, one semester on, what worked, what didn't, about the curriculum, about the tools, about the way the classroom was set up. And that fuller study has been accepted at NIME 2023 and will be presented there. And then this this spring, they have another performance scheduled for this Saturday, actually. They've got a further performance, and they'll be visiting some of the research labs at New York University. And then beyond that, this summer, we'll have more time to kind of pick up all the loose threads from the year and really start to identify and kind of sort through specific issues that came up. It's important to design these sorts of things with the active input and involvement of the people who are actually using them, but it's also particularly tricky to do that with students who kind of don't necessarily yet know what it is that they need to be sort of designing. So now that we've got this initial class of learners who will all be potentially, can potentially continue on with the ensemble in future years, now they have some expertise and can help sort of take a more active role in the kind of ongoing development. And the school is very interested in expanding this ensemble. We're trying to figure out how to make sure that there are more people who understand live coding, understand how this works, just build up the kind of momentum to keep things going. And yeah, I'll wrap up by saying thank you to the FMDG school, all of our research assistants at NYU, in particular, there was Shinran Shen and Eric Xu. And also thank you so much to the 5 members of our ensemble for helping us figure this brand new thing out. And thank you for joining. Bye.
Okay, thank you so much, Matthew. there any more questions? There's no more. Well, we have a little bit of time after this, so maybe 2 or 3 questions, if anybody has any. You can leave the laptop there, it's fine. Just.
What's text-to-speech? Has that been something you've investigated, and what limitations do you see within that, also considering some of the recent developments that we've seen with things like Google Copilot?
Yes. I mean, you know, so text-to-speech is built in, you know, sort of natively a part of things like VoiceOver, things like JAWS is the popular Windows screen reader. And, you know, so it's, I mean, to some extent, because, you know, because these are the like the accessible tools that people are using all the time, we're not really dealing with things at the text-to-speech level much, because, you know, they, like a blind computer user gets really good at the exact, you know, sort of voice of VoiceOver and figuring out how to pick up even like a very fast reading of a bunch of text on a screen, how to sort of move forward. You know, that said, there is the sort of future design that needs to be done around this is kind of how to augment just the basic reading of text with, okay, are there maybe audio cues, or are there certain kind of things like that? And with that, I think there's, yeah, a potential to sort of play perhaps with text-to-speech engines at a lower level to, you know, find ways that subtleties of voice could indicate that code is being actively edited or something, you know, things like that.
Okay, one more question over there.
Yes.
How does a blind person read its music?
Oh yes, how does a blind person read music? I mean, you know, again, it depends on exactly how much vision they have. There are lots of musicians who will use large print scores, which, you know, both are sort of physically larger, but also might be more simplistic. And there is also a full system of Braille music notation that has been, you know, basically all of the relevant sort of pieces of music notation have been ported, to use the tech term, over to a sort of Braille representation. And, you know, it's the sort of thing where there are going to be as many solutions or as many sort of variants of solutions as there are blind musicians. And so, you know, anything you want to, what you always want to think about when designing in this space is building things that are very customizable, that are very easy for people to kind of own and use on their own. Yeah.
One last question, maybe? Yes?
Yes.
Can the blind people, I mean, can monitor what they have written already? So can they monitor the prescriptive part of the notation that actually does things?
Yes, you mean in terms of like the actual code of
yeah. So if
title.
you type like a line in Tidal,
yes, exactly.
Can they track this with the paper that you mentioned, this technology, the shape changing paper?
Yes. I mean, the paper handouts are of course entirely instructional, but they're using like a Braille display, which essentially has like little actuated dots, so that it can, you know, you place your cursor in a line and, you know, just like a monitor, it generates, you know, all the dots rise up to show you that line of title, and there'll be like a blinking, you know, a couple of dots that sort of jump up and down as a sort of indication of the cursor. And also, you know, if you're using VoiceOver, you'll, you know, enter in and it'll say, okay, you've entered a line of text. The line says $, it's, you know, et cetera, et cetera.
Yeah.
So you...
Yeah, so I mean, there is this distinction between prescriptive notation, the notation that does things, and descriptive. So the cursor would be there, the descriptive. It's somewhere there, doesn't do anything really. If
right.
Or the highlighting, for example, in Strudel, the event highlighting, this descriptive notation. So
yes.
There are any technologies for descriptive notation?
Oh, right, descriptive versus prescriptive. At this point, it's getting the prescriptive notation is a lot of challenge on its own, but certainly, exactly, those extra, layers of descriptive understanding is, in the same way that IDEs for sighted people are still trying to kind of figure out how to implement those things, then that's work for us to do as well. Cool. Great.
Okay, thank you so much. Another great applause for Matthew. And all our other amazing presenters of the day. Don't run away just yet, because I think we have a short announcement, unless we accrued too much delay. Sorry, we apologize for all the technical problems we had. Is there still an announcement happening? Die Anwendung? Fabian? So, die Anwendung, if I pronounce it correctly. Okay, then there's no announcement about NIME. I'm sorry about that. So this concludes the academic part of the day. We'll have some time now, and then I hope I'll see you all at a concert. There's a concert tonight, or am I completely off today? No. Okay. Let's call it a day. See you around. Bye.